personal? We can bring it or?
It's for you, including the pen also. The pen is for you complimentary. Yeah, this one is mine. So, quite less screwdrivers with me. And the pen is not some normal pen. It has so many features inside.
Yes.
And if you twist the top part, it's like a screw. It has a screwdriver.
Okay.
I mean, you just twist it, open it. Swing. Hey. Morning, boss.
Morning.
Sorry, I wake up late today.
It's okay lah.
I started to. So yeah, during tea break, 15 minutes tea break, then we go, okay? Even Vivian also had to go to UTM and check on the chamber project. Yeah. And then I think probably he also went back home late. That's the problem, lah. Some client give us a project during a training peak time. Then we have to do both together. Take a breakfast.
Yes.
What do you have?
There's coffee and it's like cookies or something.
Oh, you mean you just bought it in the shop, not you didn't have your breakfast in MBS?
No, at the restaurant.
At the restaurant?
Yeah, restaurant. Not outside.
Okay. The normal restaurant. Cookies.
It's like cookies or bread type or something. I saw on the.
Is it crunchy?
Yeah.
Then that's roti canai. Yeah, that's the one I WhatsApp to you.
Yes.
Oh, you showed to him then, is it?
Uh,
That you want that?
yes. You WhatsApp to me on the.
Roti canai telur bawang. Yeah. When it comes to roti canai category, that's the best one.
Yep. Really is the best. Only the best, I would say. For the breakfast.
Telur bawang lah. Telur bawang dua garing.
Yeah. Probably, I think.
Some will banjir lah. Banjir means they will put all the curry, mix it together. I don't like to mix it. I just like to keep it separate so I can just touch and eat. It will be nice. Yesterday what you had was a national dish. Malaysian's national dish. This one also kind of. So yeah, when you travel with your family over here, or holiday over, the best part about this country is food. You can get all type of food over there. So it won't be an issue. Hey, you want to get a laptop? You worry?
Yes, but later we finish training, okay, we can check the laptop.
Want to finish the training for today or?
Maybe tomorrow or next day.
Tomorrow and next day, yeah? Yeah, it's because today is Thursday. Better to check by tomorrow itself. But I scared that Saturday because he does. I mean, the shop is open on Saturday, Sunday also. But sometimes the stock or not, need to ask them. Just need to know the specific.
Yes.
The spec like you want i5 or i7. Normally they always have the newest generation. i5, i7, because you want to install TIA portal, at least minimum must have 16 GB RAM. And when come to SSD storage, at least have 1 terabyte, 1 terabyte of SSD. Should be just nice. You can run a project. And once I receive the laptop, at least I need 1 day to help you do the installation, set up, check the laptop condition and everything.
Good morning.
So once you have decided, you can just WhatsApp to me.
Yeah.
Which one, which spec, one i5 or i7, and how many GB RAM, if you want 16 or 32 GB, is better, which you can install more software inside, so it will remain stable. So what time is the event? What time is the event? Morning event. 10:30, 10:15, I will take him to change. Here what right, what change the remote? Yes. Okay.
If all okay, you can just create a new project. Day 2, lesson 1. Then what we do? Add new device. Because we're doing new project, right? So add new device. Open, okay, DC, okay, 4.6, okay. Done. Okay, next. Finish. Okay. So we are not adding anything, right?
Yes.
Okay. So once we done, then go to all tag. Show all tag. Okay. So what do you do? The first two push button you create start stop. Then maybe you create 3 lamp. Lamp 2 you name it as a motor. Motor 1, motor 2, motor 3. 2 input start stop and 3 output. Save. Go to program log. You create a simple program. Start motor on. Then when I stop motor off. Go to main. Then you can create a simple program, the start stop motor. So when I start motor on, okay, then the output is motor 1, yes. Where's the one? Motor 1. Okay. Then you latch it because the start button is push button, right? You open branch. Okay. And here and stop button. Okay, you save, download first.
Should we open our module?
Oh, you power off this. Very nice. Why? You download already?
Mm-hmm.
Not yet.
Okay.
Not yet. Start search. Okay, load. Continue. Okay, finish. Okay, this one. Okay, monitor. It's a simple program, right? Okay, you click the start button. Okay, and go done. Start stop. Okay, now what I want to do, go offline. You can go offline means you can press this or press this also can. Here go offline, right?
Oh, okay.
Can also have. Okay. You go to device configuration. Okay. You open this. Yes. Okay. So why you the start button? Why you use I 0.0 and 0.1?
Equal.
Input. But why 0.0? Because ours start with 0, right? Let's say I want to change to other number and we see what happens. Okay? Okay. You change to 2. Okay? Okay, wait now. So when you change to 2, do you see do you want to assign with what your address means? It's asking you whether you want to change the start stop or not. Okay, into 2.0, 2.1. So I don't want to do that. Okay. Do not change tabs. Okay, okay. Now my physical is 2. But in the program I is using 0.0, 0.1. So we see what happened. Okay. So I do some changes on the hardware, right? So if I do changes on the hardware, I right click the CPU. Download to device, hardware configuration. Yes. You don't think anything happens. Okay, can you see it asks you to stop, right? Okay, wait. So every time you download hardware, it asks you to stop. Okay. Now your output is on, right? You on, you leave it on. No, on. You leave it. You press that, you also can. Is it on?
Yeah, but I know I put the output, I know the tanking there already.
Oh,
Because this one the tanking I put the input there.
oh okay. now you on, right? Okay, you press load, this is what happens to your output. You see your output off already, right? Okay, why? It's not because we changed the address. Okay? It's not because of we changing the address, because whenever we download something, hardware, or first time we download or hardware configuration, the PLC will go to stop mode. Correct, that's why we ask you to stop, right? So when PLC stop, all your output will cut off. Okay? So if you're doing this for your machine, you must know. Whenever you download, it asks you to stop the module, then you must know, okay, is it safe or not? If I stop the module now, is it the machine is safe or not? Because sometimes we suddenly stop the machine can damage the machine, right? So we need to know. Okay? Okay, now finish. Okay, go back to the main. That one no problem. Go to main. Okay, now monitor. Okay, now you press start. Nothing, right? You know why? Because cannot on this one.
But the numbering here won't change.
No, just now I choose do not change. Because I want to show you. If the hardware is different, here is different and it won't work.
Let's say just now we press the change, so meaning that the
In here automatically it become 2.0, here 2.1. Because earlier we already used the 0. If I change in the hardware, it will automatically get update also. Okay, but here I just want to show you that if the hardware is 0, you can use 0. If the hardware is 1, we must use 1.
Then, what is the purpose of this? Like we change to
It's because we can.
why we need to change? What kind of the
No,
program?
normally we don't change. Always 0, right? Whenever we add new one, that one only we do changes.
That means that add a new.
And when you add new,
Okay.
it give you some random number, right? So I change to the next input, next available input numbers.
Okay, that means like for example the first level one we always I0.
Not network one. We don't talk about network one.
Okay, at the first
The
program
address.
then we all put at the I01.
Yes.
Then the second one.
So please let me see. This is the PLC, right? Okay. So input, let's say now we have 8 inputs is sample, right? So let's say okay, what happened, it will show okay. The input is 0. The output also 0. This is the byte number. Okay, so when we add a module, and let's say we add DI 16, okay? So what happened? Automatically it give you some number. That is, the it is let's say 10 to 11 for example randomly. So but input you just only use 0. So next available is 1, right? So just change this to 1 to 2. Because got 16, right? So this is 1 byte, this is 1 byte.
Okay.
So that's why we do changes. So when we add some output, DO60, okay. It will give you some number, like example 5 to 6, for example. When it give, actually we can use this also, no problem, right? But when we do programming, it's easier. So I change the 5 to 6 into 0, so 1 to 2. So we can arrange our addressing first. It will be easier to do programming. Because this is the output, right?
Yeah, this input there will be 3 to 4.
Yes, correct. Okay, ready?
Okay.
Okay. Now what we do, we go to the address change factor. Okay, now you see, cannot change. Why? No, because very simple. When you are online, you cannot do anything to the hardware. So I need to go offline. Then you can do changes in the hardware. 0. Okay. So can you see when you go back to 0, it didn't ask you to. It didn't ask you like, do you want to change? Right? No, because the software already know. In the program, in the tag table is already 0. So it didn't ask you to whether you want to change or not. Okay? So we do changes in the hardware, download again the hardware configuration.
So when you looking at device configuration,
What's that?
we need to do redo the device configuration.
No, we already done, right? So
Okay.
you need to download. Right click the PLC. Download hardware configuration. Yes. Because we do changes in the hardware.
Do we need to upload to the PLC?
No, upload, download.
No, after we the system configuration, do we need to
Download,
download?
yes. Yes.
Hello.
What?
What the here is on. See, this one. This one is already on.
It's not on. It's off.
Off. Then when I press the button, yeah,
Press the start button.
yeah, press the
Press the lead.
yeah.
Okay, good. Okay, go offline.
Oh, sorry.
Why? You go to your hardware configuration. You changed already, right? Have you download the hardware?
Download.
Ah.
How to download?
Once you finish this one,
Yeah,
and if you do anything with the hardware,
yeah.
you right click the PLC, download to device, hardware configuration.
Okay. Need to download that.
Yes. Yours okay?
Okay. Already download.
Yes.
Yeah.
So if you do anything with the hardware, it's a configuration. If you do anything with the program, it's called software. Download software.
don't come with the download.
Yes, because you're online.
Oh, they may have the offline first.
Yes.
They may go offline, then only can
Download.
Okay.
That is compiled.
Okay, yeah, yeah. Okay, next.
So yes. Okay, next. So now what I want to do is I want to add a timer. Okay, to cut off the motor. Okay, so what I want to do when I start motor on, then after the timer I want to off the motor. Okay. Okay, click here.
Click here.
You add a branch.
Branch.
Okay, add a normally open.
Open.
Add the motor.
Motor.
Yes, the motor one.
Okay.
Then you go open the instruction here.
Instruction.
Go to timer operation.
Timer operation.
Yes. Then got many timers lah.
Yeah.
TP, TON, TOM, RTO, everything. Okay. So TP means timer pulse. Means you just give one pulse, it will run for your timer value. What is your set point lah? Okay. Then that's all. Finish. Okay. TON means you give the input, the timer will start to run. After the timer, then only the output. Okay, that is called TON lah. Okay. Then TOF means that if the input, output straight away on. There is no timer running. If the input off, then only the timer will run. Then only, so it's called timer off delay. Timer on delay means the TON is timer on delay. So you give input, after delay, it will give you the output. Okay, but never mind, later we try some. So normally, commonly we use the TON. So you take the TON, yes, take drag and put it.
Right. Put here.
Yes, okay. Wait okay, wait. So, can you see? It shows what? Single instance DB, right? If you call the function block as a single instance, the function block saves its data in a data block. Okay. Means this timer is a function block type. Okay, function block means inside there is a coding. Okay, so means you just give the input output. It can work inside. Inside there, of course, there is some programming inside. Then it will give you the output value. Okay. Now, since this is the function block, what you do? It will save the data inside the data block. Okay, but when this one, never mind. Later we will learn our own function block. So that time we can understand better.
Okay.
For now, we just use the timer. Every time we use timer, just put, because earlier PLC's timer is not a function block. Now inside here, according to their IEC standard, they make their timer counter all as a function block type. Okay, but later we will learn what is FB, what is DB. So we will be clear. So this one just put the name timer 1.
Can we say like timer for motor one or something like that?
Can
We can remark there lah.
Yes, if you the names is up to you. Okay, the name is up to you, because later on you're going to save all these files to your laptop, right? So later on you will open these files, refer everything, right? Name is up to you. Even you can put the short form lah, TMR, also can. Motor 1.
Motor one.
Yes.
Yeah.
Yes.
Oh, okay.
Okay. Alright. So can you see the timer have an input? PT means preset timer. Q is output. ET is elapsed timer. Means the timer counting lah, the current timer.
Okay.
Okay. So can you see this one red color, right?
Yep.
If you see red question mark like this, means you must key in something. Okay. If it show like this, means if you didn't key in also no problem.
Oh, this one no problem.
No, this one no
Oh,
problem.
okay.
Okay. Why? Because you see, you open the system log, see? Program resources. Can you see the DB is there? Just now you drag, right?
Yeah.
So you open the D. Can you see the PT, ET, EQ is there?
Yeah.
Inside the data from the function block, it will save here. So that's why the ET, if you didn't key in also no problem. Because the data block will keep the values. So if you want to use, then you can call the value. Call the value out lah. Okay?
But people normally won't do that lah.
Depend on if you want to know the timer, you can use. If you don't want to know what is the current timer, running timer.
Okay.
So here also now we don't put. Later when we use HMI, we want to know the timer running, then we can use.
Yeah, again, what's PTT?
PT preset timer.
That means the timer we set.
Reset.
That means we set 5 seconds.
5 seconds.
They will run 5 seconds.
Yes, correct.
ET it calculate the second.
Yes, elapsed. They call actually ET means elapsed time lah. But when you go inside, they call current timer. Okay. I will show another thing also. We go back to the main. Okay. If you want to know how the timer works, right? Okay, you go to the time TON. Okay, wait there. Okay, this way. Okay, so you open. Delay the setting of Q, right? Okay, you open this TON. Delete. Wait a minute. Okay, not this one, only pressed. Go down. I mean,
Close ah. This one.
yeah,
Yeah, again.
again, the first one.
Oh, the first one.
Yes.
This one.
Yes, correct. Okay. So it will explain lah. Okay, what is this, everything. Okay, I'm gonna go down.
Go down.
Go down.
Oh, sorry.
No, it's that. It's here.
Okay.
Go down. No, here go down. Okay, so here the explanation lah, what is PT, everything ah.
Oh,
Go down. Go down some more. Okay, can you see? Input. A means is an input. So what is the description? It says part input. PT is duration of the on delay. Okay. Q is the output. ET is the current time value. Okay. So for S7-1200, okay, it's a Boolean. Time. PT means time. Q means Boolean. ET means time. Okay. The memory area. So means that inside here I can use in QMD. Okay, we use right in QMD, right? IQ memory data block. L means it's a long. They call it's like a local value like, or constant. Okay. Alright. Q of course. Q output we can use constant lah. Okay. Go down. Okay. Here it shows you know what. Okay. Where is the in? Go up. Up a little bit down. Here, if the in is on, right? Here is on. The ET, this is my PT value. Okay. So ET start to count until I reach the PT. You see the Q will on. Okay. Then the Q stay on. If the input is off, the Q also off. Your timer also becomes 0. Okay. Then if the input on again, I will count. If the input off, then I off. Okay. Then same thing like here. Okay. Go down. And it will give you a small example. Go down and it will give you a description how this one works. So if you want to learn something, you can use this function also. Information.
Okay. Like the POF, POF.
Yes. So the best practice is once you see here, okay, you use something example like this, right? just go to your program, just key whatever is needed, just try run and try to observe. That will be the better understanding. Okay? Can you close this? Okay, go back to the main. Okay, so here they say what? Time, right? Okay. But at the same time, in the PT they say you can put I, you can put Q, you can put M, data block or constant. Constant means you straight away give the value. Okay? For now you just put constant. So put 10 second, 10 S.
Then S.
The S is must. Okay. So when you put S, it will read as a time.
Okay.
When you didn't put S, it will read as a normal decimal number. So what happened is, you bring the mouse to the orange line.
Mouse to the orange line. This one.
What is yours?
Time. The work. Did.
Okay. Double word, double integer. Okay? Yesterday we see double word, right? Because our input or output or memory, right, can be boolean, byte, word, double word. Right? Okay? So double integer also same thing lah, but later we see what is the difference. Okay? Time means again I need to give in seconds, must put a symbol lah. For double word, double integer is you cannot put the symbol, just a normal decimal number. Okay? So 1 is equal to 1 millisecond. If you key in 1, it becomes 1 millisecond. You remove that, remove the number. You just put 10. Enter. What again?
10 milliseconds.
Millisecond. Okay? Because when you key in 10, what happens? The value is, so the TON will think, okay, the value is in this format. Okay? So in this format, 1 is equal to 1 millisecond. So if you want to key in the timer value like this constant, put at the symbols that you needed.
Then how to put the symbol like one?
No. What I mean is, if you key in 1, it means 1 millisecond.
Okay.
So just now you key in 10, right? So automatically 10 milliseconds.
If I don't want the millisecond, I change.
Then you change. No, what I mean is, when you put timer, put with the symbol. If you didn't put the symbol, it will read as this number.
Oh, then automatically will read
Yes,
that.
that is automatically can change.
Okay, that means like we need second, we only can like put 10S or something.
Yes. So this one can go up to 24 days lah, the value here lah. Can go up to 24 days.
Okay.
24 days and
If like 1 minute, then maybe we have to put 60S.
no, you can put 1M.
1M. Direct 1M.
Yes.
Right, M.
Yes. That's why I said, if you want to put day, 24 days also can put.
This is a 24D.
Yes. So 24 day, then hour, minute, S, MS.
Like this. Okay.
Okay.
Then like 1 minute, 1M. This is 1 minute.
Okay. I will tell you how much is this one and why this value, why cannot more than this. Okay. First you put 10 seconds.
10 seconds.
And okay. Then after the timer, the ET no need lah, ET later you use timer, HMI. After the timer, the Q, right, and the Q, okay, here. Because the time, once the timer is this is the motor, right? Once the timer reach, the timer will give you the output Q. So we need to save this value in somewhere, right? So what I do, I put a memory here, M, because I can use the output, Q, because it's a physical output. Means I put a memory, so memory I can start with any number lah. So maybe M0.0. So what happens? The output value will be stored inside here. Then later on I can use this anywhere I want. Okay? So that is the function of memory. This is what we call, this concept lah, we call as the internal relay. That's why the memory all they call internal relay. In Omron or in Mitsubishi all they call sometimes, there's a few names lah, internal relay or auxiliary relay, nothing like that. So, okay, you create one output, create one output coil. Yes. Okay. Then you give it a name. I mean, give the address. Okay. Now, first, this address is not in your PLC tag, correct?
No.
So, because why we didn't create? Because we don't know what memory we want to use. We only create start. I mean, we only create input and output because it is physical. We have the buttons and everything, but memory we don't know what memory. So, just key the memory here.
Memory.
M0.0. Enter. You can see automatically become tag 1 because no name, right? So there's two options. You can go to the PLC tag and change the name here, or go back to me. This I can make it. Go to me. No, go to me. You don't need to go to that. You right click here, rename. Also okay.
Name.
Yes. So what is the function? So I want to use this to off the motor 1. So you put motor 1 off.
Motor 1 off.
Yeah.
Change.
Okay.
Right.
Alright. So for your start button also same, you know. Let's say you didn't create the name. You can directly key in the address. It automatically become tag 1, tag 2, tag 3. Then you can rename also. Okay, if one finish, we save, download. We test this timer first.
Continue.
No. You see, when you are downloading program, no need to offline. Whether it's online, offline, not an issue, no problem. Okay, but when you want to download hardware, need to offline. Because you know why? When you're online, means the PLC is not talking to your laptop, so you can change the configuration. So that's why we need to cut off the communication. Then only we can change the settings. Okay, monitor. Then you press start.
Oh my.
Stop. Start again. What happened? When the input on, start to count. Once you reach your set point, the output will on lah, like the Q will on. Okay, you stop. Okay, so means if we see this, we understand this means if the input off, the output also off. Correct? So that is how the timer works.
Okay.
In front here can be anything. For now, for this project, I use the motor lah because why? I cannot put the start button here. Because start button, when I press, yes, the timer will start to run. But the moment I release, the timer will reset. Because the input is off. Okay, now you start again. Okay, halfway stop. Okay, they reset. Okay, can? Understand that? that is how this timer works, TON. Very simple. TON is when the input on, I will start to count. Once I reach my set point, I give output. If the input off, I will reset, the output will off. Okay? So now what I want to do, I want to use this to off this motor. So this is the internal relay, right? Means I can use their contact. Correct? So I put here, normally close, normally close. Okay. Then use that M0.09. Okay, download. Okay, wait now. You are on. Wait. Okay, just now when you do changes when they are online, right? Not an issue, no problem. You automatically, the program will automatically monitor off. Okay, but your PLC, your TI portal still online. Okay, not an issue. Can you see this one? Okay, it's what I think yesterday also you see all this, right? It means you bring the mouse here to here. It shows online and offline different. Means online, offline is different.
Now online is previous.
Yes, online is inside here. Okay. Okay. So you can click this download. Or even you can right click here. Download to device. Software only changes. That is okay. Okay, let's see.
Oh. Okay.
Got it?
Got it. They mean the timer after the reach timer, right? It will pass through the current. Then the current will call the motor one to off it.
Yes, correct.
Then the off, then motor lamp will be off.
Yes, correct. So when motor off, this one also off, right?
Yeah.
And this one also off.
Yeah.
So when this one off, this one reset.
Yeah.
Reset, motor one also off.
Yeah.
That's why you cannot see the motor. This one now you can see is on.
Yeah.
Very fast.
Yeah, very fast, very fast.
Yes.
So, oh, okay.
Now you can see the movement is on, straight away cut off. You can see.
Okay.
Okay, now go. Okay, good. Understand?
Yeah.
Okay. Now what I want to do, okay, go offline. Now I want to use this this memory to on motor number 2. Okay? Okay, how? We can go to the next network. Next network. So what happened for the network 1, you go up, I can name it here, motor 1. Motor 1 running or motor 1 control or something lah.
So,
Motor 1 also can
second.
by timer lah. Yeah. Yes. Even you can put comment also. Comment is based on you lah. So if you want to put some comment, yeah. No. 10 second delay. Okay. But what I mean is like a comment. Okay. If you want to key in timer, put the symbol S for the timer, something like that. So So, but never mind, here not important. But for you, if you want to later install in your laptop, right? You do one project. What do you do? Okay, you create like this one timer function, right? You describe how it works, everything in the comment for your own reference. Then later on, okay, you learn others, right? So later, maybe end of the class or after the class, right? I mean after the training, you can create one project. Inside that project, you can put all these functions, whatever you learn, everything inside one project, and you put description. Okay. If you're using counter, okay, put the description, how the counter works, what are the values you need to key, all that. So later on, when you do project or troubleshooting, easier for you to troubleshoot. So suddenly you see counter, you don't know how the counter works. Okay, you open your project and see, because in your project you put some description, right? Okay, so now here motor 2. Put motor 2 here. Okay, put here the memory. Normally open. Okay, the same memory M0.0. Then you put the motor 2 here. Output motor 2. Right, put it. Okay, then latch it. Put normal motor first. Motor 2 latch. Yes. So because you see, once this memory on, I on this motor. The same memory there I off lah. You see, on top I put normally close, right? Because I want to cut off. Here I want to energize. I want to on. Okay. But why I latch? Because this memory just now is on off button. Like a push button. Okay. So that's why I put latch. Then you add a stop button here. The same stop button.
Have to pull from symbol to the line, or can we can make it easier? I mean like
Okay, then you click here
click here.
and click the symbol also. Okay. Yes.
Okay.
Okay. Now this one says download and you test and see.
这样看下来了，你手动那边看它其实需要你。
Morning, mate. No, I will originally not today, not today. Later my admin, no worry. Later my admin will let you know, don't worry, we know the procedure, right? So that's why after we arrange. Okay. Okay, no issue. Okay. Alright.
Okay.
Yeah. I do not expect it. I cannot. Yeah. Cannot.
Just put normally open there.
Later.
You put another timer, is it no?
I just want to after this one on, right? After few seconds I on back the.
Yeah, no worries. Later we do.
Yeah.
This one you understand?
I understand already.
Okay.
Yeah.
Still you okay?
Okay.
Process you okay? Okay. Now what I want to do, I just want you to.
Then how to delete the tag number? That's the video, right?
Yes. Okay. Now what you do? Okay. Now we have start button, right? Then we have the stop button. Then we have motor 1, motor 2, motor 3. Okay. So when I start motor 1 on for 10 seconds, right, just now. So 10 seconds after that, motor 1 off, motor 2, go to motor 2, right? So now what I want to do, I want you to motor 2 on ready, okay, run for 12 seconds, then motor 2 off, go to motor 3. Motor 3, maybe 10 seconds, the timer is up to you, lah. 10 seconds, then motor 3 off.
Okay.
You do that first. Okay, you try. So for another timer, you take another timer. Another memory, you put another memory. Don't use the same memory. Because, okay, very simple. For anything that you use as the output, okay, you see, like yesterday when you try, right, so many some functions. You see, it normally open, normally close. You can use I. You can use I 0.0 also can, Q 0.0 also can, M 0.0 also can. Okay, for both that, right? For both normally open and normally close. Because this is our context, right? So of course your input I must use here, no choice. Because it's an input. The output you can energize the output, then can use as a normally open, normally close. Memory also same, because memory is not an input or output, it's a relay, internal relay, right? So memory is same. You must energize the memory, then can use. Or this memory you link to your HMI, then can use as a normally open also. Okay? That's why we use, you energize memory, then we use. Right? If you already use this at one place, you can use again at another place. Remember yesterday for yours got some issue. You on the motor for two places cannot on already.
Yeah.
Because why? You see, let's say example I put at this one. I 0.0, Q 0.0, latch it, I 0.1, okay? Then later down there, what you do? Okay, I 0.3, let's say the selector switch up. You on again, Q 0.0, what happens? Okay, it's not wrong. The program won't work properly. Okay, why? Because you see, okay, we need to understand how the PLC works. The PLC, how the PLC works? PLC is continuously scanning your program. Okay, so how? Left to right, top to bottom. That's how the PLC scans. Okay, so first, maybe this is normally closed right here. So you press start, right? So what happens? Okay, this one energize. Okay, on here, latch it, right? Okay, then you remove your N line. And when the PLC comes here and see, it's not on yet. So what happens? It will off the output. If it is off output, what happens? It will off this. Correct. So it will off your this output also. So what happens? If I put slow, right? If it is very fast scanning, what do you see? You cannot on the output. Because actually when you press the start, actually here on. But when the PLC goes scan here, it will off. So it's like continuous inside the PLC, according to the theory, inside the PLC is like on off, on off, on off, on off, on off. But physically you cannot see it's on. Okay? But because it's wrong, it's not it's not error. If it is error, it will show error. Okay? If this one you doing in Mitsubishi PLC, the same output 2 times, I will show output, but no error, still no error. It will give you warning. If you do the same thing in Allen Bradley, it will tell you duplicate output, give you warning. In Omron also same, it give you warning, but no error. But Siemens, it won't give you error or warning. Means you can do like this. If you put a latch for this. Why? Because when I start here, this one on, here on, right? Here also on. So you can latch it on this. Okay? Earlier we don't have this. Okay, earlier we don't have this. So what happened? When I press start, here on. Here can on. But the moment PLC come here and scan, see this one is not on, so what happened? It will cut off. So it's not a, so it means it's like a programming conflict. So it's not a good programming. Okay? So if you want to do something, okay, when I start motor on, then it can off lah. When the sensor, let's say sensor on, I want to on the same motor, right? The motor is already there, right? So what I do, I pick up this, I add here, I 0.7. Because the purpose of this input is to on the motor. So motor is already here. It's like if you just think like a physical relay. For one motor, normally how many relay you have? One relay, right? Or one contactor only, right? Right. Okay, one contactor. So anyone want to on the contactor, all the wiring must go there, right? So same concept. Okay. But it's not mean you cannot do two times. do 2 times also can. Like this. Because it didn't give you one error, right? If it didn't give you error, it means it can do. Unless I put a lash and it can work. But the programmer normally don't prefer like this. You know why? Because difficult to troubleshoot. Let's say this one got some interlocks, right? Okay. Then this one got so many, like for example, like this lah. So many interlocks. Okay. Now, let's say this output is the one problem now. So what do you do normally? You will troubleshoot, right? So how we troubleshoot? From the output we will check. This is what we call reverse engineering, right? Then from here you troubleshoot. Now the Q1 are you at 2 places. Now I don't know which logic is the problem or which interlock is the problem. Difficult to troubleshoot. If all this you put inside one, is easier. Or if you have something multiple like this, what I do, I take out this. I put and memory. Here also put memory. Of course, like I want to use memory. Same. I put here is memory 1, here is memory 0, right? Then down there I put and 0.0 or and 0.1. Any one of these on the much more easy to troubleshoot. If so many interlocks. So what happened? When this motor not on, I see here, from here I know already which one. This one not on. Then I go and troubleshoot here.
Use memory.
That is the function of the memory inside our PLCs. But memory also you see, I use different. If I use the same memory, it's apply the same the concept. Because most of now we are program all simple program. So the Q directly we can put here. But if you see some machines normally, they will put like this. So even I do program sometimes, I do like this also. Because so many interlocks. Actually I can put this one here. Then it is complicated. I don't want to add this here and make it messy. Make it simple, put one memory, make it simple, put another memory. Use these two memory to on your output. Okay? Okay? You try this. Okay. Want a coffee or tea? You can make a coffee or tea. Yeah. how it works?
How to omit the first one?
Okay.
Sure.
Okay. But the last one is wrong.
Okay.
Okay, why wrong? Because you cannot energize an input.
Oh,
Correct or not?
okay.
Mm.
I cannot analyze.
Input.
One question.
Yes.
Hey, let's say I want to start this one,
Mm.
second one,
Mm.
and also like the third one to this.
Alpha.
Yes. That's it. This one,
Hey, you are doing something?
yeah, doing something, trying something.
Yeah.
So I make it right, but this one, no. Oh.
Okay, where is it? Is
So I give the signal to this one, but this one I don't want to close. So without close, yeah, the memory going to here. Second one.
No, no. Who cut off this one?
I'm using the time second. That's I try the second.
Alright.
One,
Why? Which one? Where is the another one?
yeah, this one is 1 second.
Mm-hmm.
This one is 2 seconds. This one is 3 seconds.
Mm-hmm.
So I try it on the second to make it
Link.
ring. But this one why cannot? I find it.
No, where is the left two?
Then 2 is this one.
Okay.
And also even I put this one and 2, but this one didn't cut off.
Yeah, won't cut off because this one still on. Go down, go to number 13.
But this one,
Left 3, left 3. Go to left 3. Yes, go to number 3.
okay.
Because left 3, you see this one off for what? This one off already, you see? For
Yeah.
1 second is off. So that's why this one can cut off this. So you go up,
Okay.
you see this one is always on. Can you see? So you cannot cut off this.
So how
You go up, you need to use use the logic cut. Okay, 1 second. Okay, go down.
okay, 2 seconds.
This one, because you can't use that timer, so you need to use another timer for this. Maybe.
And something else. Okay.
You can use this here.
Oh.
Oh no, still cannot. But can do lah, but need to modify it a bit. Yes, so
Inside this one, how many timer have?
timer.
Oh.
Timer, we need to use.
So we don't need to add external timer. Don't need.
No timer. That's why we're using PLC.
Oh, so let's say we're doing
The
the.
PLC is actually replace your relay,
Mm.
replace your timer, replace your counter,
Oh,
all that replace.
only the contactor can replace.
Contactor also can use, but of course that contactor the load is high,
Yeah.
high load, right?
Mm.
So that's why we need a contactor lah, because contactor is for high load.
The motor.
Motor, yes, 3-phase, right?
Mm.
So that's why still using contactor lah.
Mm. So this one we can use timer to make it bring.
Can, but different lah. But the one will be can do, no problem.
That's curious. That's curious.
Can, no problem. Can. So what I do is because why your number 3 motor can blink, because number 2 motor the timer can off for a while.
Yes.
But for number 1 motor, the timer is always on. That's the thing.
So I need to make the timer the.
Okay, what you can do.
Okay.
Okay. How many second blink? You mean 1 second blink?
1 second ring.
1 second on, 1 second off.
This one is 3 seconds off, 1 second ring.
So how you want? You
Let's
want
say,
1 second off, 1 second on, or?
let's say I want the second one ring 1 time, 1 second,
Mm-hmm.
close 1 second.
Mm.
Then this one ring 2 seconds, close 2 seconds.
Okay.
So at the same time, this one will bring together.
Okay. So what happened is,
Yeah.
so first you need to create the timer to blink.
Okay.
Okay. So what you do? When I press start, okay.
Okay.
Because the motor one is always on, right?
Yes.
Okay. from here the motor one, the timer, I put T1 okay, this one 1 second blink, right? 1 second on, 1 second off, right?
This one for second one or for the first one?
No, I mean the second motor.
Second one, yeah, second
1
one.
second off, right? So you need to create a timer, a pulse first.
Yes.
The timer pulse first, you use that. Timer, so maybe 1 second. Then M0.1, 0.0, okay. So start this one on, this one, okay. Then M0.0 on another timer T2, 1 second, and 0.1. Okay, so what happened? This one you put it here and 0.1. So the moment I on, right, timer will start after 1 second. This memory on. This memory will on this after 1 second. This memory on. Okay, so this one will cut off here. Okay, so I think
I don't understand.
what I want to do is I want to create a pulse first.
Okay.
Okay, so this one for 1 second, right? So 500 ms.
Okay.
So wait, 500 ms can. No, 1 second. 1 second.
Close.
1 second. So what happened? Now this memory is become 1 second pulse.
Okay.
Okay, so what happened? The moment I start, memory on. After 1 second, this one on. Then
This one on.
after 1 second, this one on, cut off. Okay. So this one will on for 1 second. Okay, 1 second on, cut off.
Okay.
1 second on, cut off. Okay.
Yes.
Then do the same thing for the 3 second also.
Okay.
Okay. Then to use this one, M0.0. That's all. So what happened? But this one need to try lah. Okay, so I use the same motor here.
Okay.
T3, 3 seconds, and here is M0.2. Then M0.2, T4, M0.3. 3 seconds, cut off. So what happened now? M0.2 will on for 3 seconds, off for 3 seconds. On for 3 seconds, off for 3 seconds. Okay? Then I use the M0.2 to 1, 2, 3.
So let's say this one, we are using the motor to control the number 3, right? We use the motor to control the number 3. The first and the second, then we will be linked together. Because this the above, so motor power supply to the timer 3. So timer 3, this one cut off M02. So M02 once cut off, give the signal to timer 4 to control the motor 3.
No, this one will cut off this. No, what I'm doing, you don't think I control this. I'm not controlling anything here. What I do, I'm creating a pulse because that's what you say, right? When I start, first motor on, second motor 1 second pulse, third motor 3 second pulse. Right? So when I start from this, okay, motor on, because this motor always on, right?
Yes.
From here, I'll create 1 second pulse. This is the 1 second pulse. This one is the 3 second pulse. This one I'm not using. These two I'm not using. This one is just for the project.
Okay.
I mean for the timer to cut off. So this memory will on for 1 second, off.
Okay.
On for 1 second, off. This memory will on for 3 seconds, off. 3 seconds off. Then I just use that to on the motor 2, this one to motor 3. So means I'm not doing like just now the previous one. When I start, you see,
Okay.
I'm not doing the program like just now. When I start, motor 1 on, after timer, motor off, then using that timer to on motor. No, I'm not using that. I'm creating the pulse first. So from the pulse, I'm on off the motor.
Oh, so we're using 2 timers as one set as a
Yes,
pulse
to create a pulse.
Oh.
Because for 1 second I need to on, for 1 second I need to off. Same like your motor 2 and 3, it's the same concept.
Okay.
Uh,
Still doesn't know it's a different. Let's say total how many timers we can do? A lot.
4,000 plus.
No problem.
No.
How my question is how to from the M02 go back to the motor one.
Okay. How? M02.
M02.
How
How to add in this one? How to add in the line?
You click here.
Okay.
Click on this latch.
Oh, that's
Okay. Because for him, you want to repeat.
Hmm.
So what is your last timer?
It's
Last timer, what is the memory?
yeah,
M02.
I need to put there.
Yes, that one.
Yeah, that's why I'm finding it.
Let's say we without putting the M02 at the first part. So this one is one cycle.
Yeah, the previous one, yeah.
Okay, so let's say we put that, then we continue.
Continuous.
We cannot.
Then, one more question. Let's say in the market, like the Christmas tree, Christmas tree, they have the ring one. They're using PLC also?
No. Okay, all that, right, is already pre-programmed PCB board. It's like a microcontroller lah. Okay, so like example, our aircon. Our aircon also is considered as automation, correct? Because you set a value, it can control your compressor, can detect the temperature, can blow the air, and inside the blower can turn, right? Okay. So got so many components, so many input. So but how it can work? Inside that there's a PC board. Inside the PC board there will be one IC to run this program. So that IC there, right, is actually your PLC. You can remove the PCB board, put your PLC there, connect all the input output to your PLC, then convert this into a HMI. You can control the other part. So because that one all is like a continuous.
Yes.
I mean it's a similar, right? So they can just program a PCB board, then can do that. PLC is you can modify. Why that one they don't use PLC? Because they know, okay, this is the program. So if there cannot be any error or something, this is the program. So they can build a PCB, okay, can fix. But in the machine, right, they cannot do that. Last time they do it because last time if you see some machines, they use a PCB board. That day I go and troubleshoot.
Yes.
PCB board means the system is controlled by a PCB board. Means it's already programmed. Okay. So inside the PCB board they already have input, output, everything. Now the problem is if one of the output is the terminal like this. If one of the output is spoiled, I have a spare output. I take out the cable, I connect to another output. In the program I change, then I can run. But PCB board cannot do that. So that's why in industry they use this because easy to diagnose, easy to troubleshoot, easy to upgrade. Have you heard about Arduino? No. Have you heard about Arduino? Sean, have you heard about Arduino? No. Arduino is like it's a microcontroller, similar concept like PLC lah, but they are not using ladder program. Okay, similar concept like a PLC. They normally university students they use for their projects.
I think they use C language, I think.
Yeah, C language. Arduino, got another one called Raspberry Pi. All that normally university students they do for their projects. Okay, good. Okay, my concern is okay. The logic is no problem. Logic you need to practice lah, but you know how to use the timer. Correct? How to use the timer, you know, okay? Then how to use the normally open, normally close, the tagging, how to do tagging, how to rename, download, monitor online. That is important. Okay? That's why I asked to practice. I mean, use something. Okay, just play. The logic wrong, logic not working, no problem.
Try that.
Yes, of course, because this is where you can do the programming. This is where you can make mistakes.
Yes.
Because you cannot make mistake with the actual machine.
Okay.
Then
mistake are bang.
Yeah, because I know the only advantage is very simple. You can download wrong logic. You can download, but you cannot download a wrong program.
Yes.
You understand or not?
Okay.
So means if your program got error, of course the software won't allow you to download. But you can download wrong logic. Yes, your logic might be wrong. Can download inside, but wrong programming cannot download. No worries. But here you can do that. But in actual machine you cannot even download wrong logic. Because if you download a wrong logic to actual machine, it can damage your machine. Because I say there's a 2-cylinder coming, going to the same place. So what happened? If this cylinder coming, this cylinder cannot come in. If you on both, what happened? Can damage.
Okay.
Okay, good. Sean, okay, can you
Yeah.
read?
Yeah, okay. Good.
Want me to install in the laptop?
Yes.
Yeah, I
Just
want.
give it first.
Thank you so much.
What antivirus is
Theoretical have. Practical I'm not sure. Theoretical have.
And what antivirus you use?
Last time is Newton. I remember it's true.
Any other software you're using AutoCAD lah?
AutoCAD.
Okay.
AutoCAD is quite. So, we have 20 minutes.
Yeah, of course. I evidence it, no worries.
Let's say you want to load this whole component. Which shop normally you go?
No, I will buy online. From the supplier lah. If you want, I can get for you one second hand or something. Check.
Or suddenly.
Yeah. Is full again? I mean, just leave it lah. If I need, I will. Okay, I want to ask you one question. Have anyone worked before with the what? Heating coil?
You need a supplier.
No, I need some idea.
Sure.
Heating
Other one KL. This one KL.
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 Oh, okay. What the company name?
NTT thing.
Oh.
Do you know?
No.
This company is quite big. There are a lot of meter. The ceramic meter, the traditional meter. Okay.
Okay. Show me the contact. Because the project I do for the UTM, right? So the lecturer designed the heater. So the chamber is this big. You know, it can, I think it's 1.8. And this big. Okay. So what happened? They use a small heater like this only. So you cannot heat up the whole chamber. Not enough. The heating. So they plan to put heating coil, you know. Heating coil, put some blower, so it means distribute the heat lah. That's right. But I never worked with the what? With the heater before.
So that's it.
Next. Check.
But heating coil, energy consumption is a lot.
Yeah, of course. For that I need to, even my panel also I need to modify it a bit. Need to use a bigger cables. Okay, this one okay?
Okay, I tried it.
This one okay. What do you do? Means we already open, close, file, timer. It's okay, right? Okay, that's what we learned now so far. If this one is okay, what you do? You save, you close, you create a new project. Then we want to learn the set, reset, and pulse function. So once we done until here, maybe we can do a project, proper project. No, let's put lesson. This is lesson 1, right? Day 2, lesson 1. So this one, day 2, lesson 2. Can I off the add hardware, then what you do, you add all your inputs. Like maybe you can put like PB1, PB2, PB3, switch 1, switch 2, switch 3, then all the LANs. No. Wait. Delete that.
Sure.
I mean number 3 delete.
Sorry.
Number 3.
Oh.
No. I mean the L. No. Can delete. You click at the side here. Delete. You click here. LG1. Okay. Want to do what? LG1, 2, 3, 4, 5, 6. Okay. You click here. Drag. Do it. Okay. Override the text.
Yes.
Can?
Shit.
But you want to it. But 4 enough lah. Okay. Now the output you want to change, right? Okay.
Yes.
Change the output. Change the output. LG1. Okay. Q0.0. Enter. Okay. Same thing. Click here. Drag. Can you see?
Yeah,
Okay.
okay.
Here.
1, 2, 3, 1. Okay. 1, 2, 3, 1.
Because the one you restart all the installation.
So, you can, how do you install this T987?
Yeah. Software we are using, they have ordered the license and simulation.
This one can do it level. This one is considered as a level.
This is the level diagram.
是有计算说看那个房间需要到多少米，根据房间的那个 volume， 还有它的那个温度。
Okay, so what you do here, put EB1, then put the coil and change to S. It's a set coil, they call it.
What's mean?
Set coil. No, man, we do first. So you put normally over EB1. Okay. Yeah. Then the output you add normal coil. Then double click the coil, change to S. Set. Okay. Then you put the lamp one, L1. Okay. So what is S? Okay. S means it's a set coil. Normal means it's a coil. Okay, it's a set coil. Okay. So you know some relay, right? There's a called some latch relay. You give one pulse, can always on. So that is called this one. Means you just give one pulse enough. It will always set, always on. Okay. Don't need to do this latching here. Okay. So if you want to off these, you use the second one. Reset the L1. This one later you going for lunch? Going out for lunch?
Maybe. Yeah.
Why? Later want to go buy some food. That's why I'm asking. Because later close the office. That's why.
Okay.
PB2跟多一个那个2，就是亏了过后里面填啊，
就是 S
S 多
SR
SR。
Set reset.
那个下面有个选，没有个键图没选，
那名字是不用你拿的，
哪个名？
就是你的那个就是带纲目。
但是我们自己放哦，
我们自己发，我们自己发。
对，我们自己放。
哦，你拿。
为什么我们自己写的那个名字？
OK。
Set down. what do you understand from here? Reset. So means just give one pulse enough. It will always set. So you don't need to latch. Okay, we need to do the holding. Means this one is similar to this. V1, L1, latch, cut off PB2. This program same, right?
Okay.
But here, you see, here the PB2 I put normally close because I want to cut off the line. Here the same PB2 I put normally open because I want to energize the line. Okay? So reset very simple. Set means the set is depend on this line. So if the line is energized once, I reset. Okay? Now what do? You go offline. Then you go to the second network. You add the same normally open. Now you use switch. Okay, you use the switch. Now set the second line.
Second line. Okay.
Then set switch number 2. So next one is the switch number 2. Yes, same. Then the reset the lamp. Then you download and test it. Whatever.
Okay, let's say push button. Even this one is holding, but the line is still blue color. This one holding, the line is still green color.
Okay, that one is no problem. The line is still on, no problem lah. Because this S is the moment it on, I always reset on it
Yes.
until I press reset. Right. Okay. Now you on the switch to whatever.
Off.
Off already, right?
Mm.
But here you see green color.
Yes.
Because this one means it's on, right? So why?
The switch is still on.
Yeah, but let's say it is a what? It is a sensor. You cannot off the sensor, correct?
Okay. Yes.
Whatever.
S you mean when press the button, light will be on.
Yeah.
R if you give the supply, the light will be off.
Yeah.
Okay. Normally what is the function for this?
Same like the normal coil lah.
Okay.
Normal coil.
Oh, like
Attachment.
they mean like start and stop button.
Yeah.
When press the start button, they only
On.
have light. Then when stop, off the light.
Yes. Normal, no need to latch, right?
Yeah.
But here, what happened? Here it look like this one is okay on, but the moment you on number 2,
Off.
off, right? But here is on, right?
Yes.
So what happened? Actually, here it's on, here it's off.
Yeah.
According to theory lah, right? Okay. Here it's on, here it's off. Okay. So this PLC, okay. If you use some PLC like elaborately, if you do this one right, it will blink. Not like blink like this. Okay. After some time, just blink like one blink. Because why? It's on. Okay. Now, so how to solve the issue? Let's say this is a sensor, because sometimes the sensor, let's say this is the conveyor, this is coming. Sometimes the sensor will always detect what. So you cannot cut off this. It means like this, I on. Let's say this is a pump to fill up. Okay, I on. Let just keep on running. Okay, so I cannot off the sensor, but in the program I can off it. How? I know this one is always on, correct? Just like one push, like a push button enough anyway. But this is a sensor. We cannot change this into push button. But in the program, we can modify it. Okay? This is where we use the pulse function. Pulse. Okay. It's a positive pulse. P means positive, lah. M means it's negative. Okay. So we have a boolean, right? All these are boolean, right? The line, okay. So boolean, how it works? When it's 0, 0, right? When it's, the moment become 1, it become 1 like this, right? Then it stays 0, if it 0, 0 like this. Okay? That's how the normal boolean work. But here I don't want to use the normally open, the normal one. Okay? I want to give a pulse. That is, the moment from 0 become 1. It's a positive pulse. Okay? Means actually the common name. So for all PLCs, they call this as a rising edge. Yes. Okay? Then from 1 becomes 0, it's a negative pulse. This one we call it as a falling edge. Means the moment it detect from 0 to 1, it just give one pulse only. Okay? Okay, so what you do, the switch one, you double click the switch one. P, yes. Okay, no, just for the P, okay, P and no, good. So the below of the pulse, I need to give a memory. Put a memory there. M, any memory used, not there, right? So start with M0.0. Put M0.0 there, and another memory, put M0.1. Not that, sorry. The question mark. The question mark below the pulse, yes. One is M0.0, another one is M0.1. Okay, now download and see. Can you see now the line is not on, right? Okay, so you already give the pulse already. Okay, second one you on, nothing happen because it's an N, right? You off, then only you give the pulse to reset the line.
Then it's reverse.
N is the from 1 becomes 0. Don't put reverse lah.
Oh.
Yeah, from
One.
1. So, P means from 0 become 1, N means from 1 becomes 0.
This is show.
From 0 become 1, pulse only, just give you the pulse only.
Mr. Steven,
Yes,
one question.
yes.
Okay, I first. Okay, that's how. Let's say this one is
No movement. Yeah,
okay,
yeah.
normal. Okay, this one is normal.
Mm.
Okay, like our house
Mm.
let's say I'm stepping.
Sure, yeah.
Okay, this at the ground floor and the first floor.
Okay,
Now I'm at the ground floor. I'm open.
okay,
Okay, at the ground floor I close it.
okay.
At the ground floor I'm open.
Mm.
At the first floor I close it.
Okay.
Now at the first floor I want to open it again using the same switch.
Mm.
How? Because this one no more.
No, I didn't get it.
Okay.
I think
Okay.
he was referring to, intermediate switches.
Yes,
Ah,
yes.
okay.
Okay, now I'm ground floor.
Okay.
I open. Okay,
So the lamp on.
lemon. I
Okay.
going up to the first floor.
Okay.
I close it.
Okay.
But sudden,
No, but don't care of the lamp.
okay, I open. Close. Close. I close it.
No, because you haven't downloaded it.
Oh yeah. Okay, yes.
Just explain to me
Okay.
like how you want.
But now at the first floor, I want to open it again. I want to using the same switch to open.
Can.
How?
No problem.
Because normally mechanical switch only. Let's say this one PLC. How?
Can.
Because we're using the switch, the current is always upright.
So this one is the switch one, right?
Yes.
Switch one, you want to on the lamp.
On the left, yes.
Okay. Then switch two cut off the lamp.
Yes.
Then switch two I
Switch again to on.
switch again to on. Okay. So means switch to the positive pulse. So means I set lah example lah.
Okay.
So I reset. So it's a positive pulse lah.
Mm.
This is a memory 0.1,
Okay.
0.2, so on. Then when this switch I off, I want to on again.
Yes.
And what the same lah, the switch 2. The negative pulse of the switch 2.
We try the program.
Okay,
Yeah.
try and see.
Okay, so this one is set. Okay. This one is M01.
M0.0 lah.
M0.
Okay.
So this one
It's a P also.
house also
P positive.
positive. Okay, so we're using
M0.1. Different memory.
Okay, M0.1. Okay. So this one is the R.
Reset. Okay. Then you want to on back the same one. You no here. You click here.
Okay. Yeah.
No, before the line. Yes.
Okay.
Now you add the branch.
Okay, now I normally open.
Same parts. Same switch number 2.
This one becomes switch number 2.
Switch 2, yes.
Okay, switch number 2.
Switch 2. Same switch 2. The same switch, this one I want to use here.
This one.
The same switch, enter. Okay.
Okay.
But use N.
Use N.
Yeah.
And close it.
Yes. Then must put a memory also, new memory.
M0.2. Okay.
Yeah.
And this one switch on.
Okay.
This one switch off.
Hmm.
We switch back again and on. How?
Huh? What how?
Okay.
Now don't have stop. No.
Don't have stop. Okay. Switch on.
Okay.
Okay. Switch off. So now this one
And so this one the
Zero.
positive pulse.
0 to 1.
Okay, wait. From 0 to 1, okay, I give the pulse.
Yes.
Okay, now you want to on back the lamp, right?
Yes.
You want to on back the lamp when switch 2 from 1 becomes 0. Correct? Correct.
Yes. Yes.
So this one.
Oh, so because we close now this one is the 1. So we turn from 1 to 0, then this one becomes open.
Yes.
So 1 0 0 1.
Yes.
Oh.
But 1 0 0 is this one, huh?
Uh,
The PR. So
oh.
this one is when from 0 become 1,
Okay.
I give the signal.
Hmm.
Here from 1 become 0, I give the signal.
Oh, okay.
Okay?
So let's say I want to make for the above switch one, then I'm making another branch on
Yes.
my end.
Yes, can.
Oh, okay. Okay. Okay.
Can I?
Hmm.
So you understand the pulse and the set reset?
Hmm.
Don't understand. Which one do you understand?
I'm still confused. Yeah, you continue. Later I think how. Later I have the vision that I know already.
Okay. Okay, maybe we do another one. Go down, which one is it?
Okay.
No, just complete this one.
Okay, on this one.
Yeah. Switch 3 still available, right? Not used, right? Okay, I want to use the switch 3.
Okay.
Okay, go down, put switch 3. Normally open that normal lamp.
Switch number 3. Okay.
Switch 3, then put the lamp 3. Lamp 3 not used, right? Not yet used, right?
Yeah.
Lamp 3. And I want to off after the timer.
After the time.
So what we do? So put here. Normally open. Put the lamp 3 here. Right. The lamp was on the timer, right? Put a timer there. Let's put timer. Give me the this.
Yeah, yeah. No problem.
Okay, put 10 seconds. Okay, then what we do? After the timer, we put memory, right?
Yeah.
So put a memory, a new memory. Okay, no, don't put 10 seconds. Now good. I give you another method. Let's say you forget because you cannot use the same memory, right? We have a conflict lah. Okay. So let's say there's so many memory. How to know? How to remember which memory you want to use? Right. So one, you can go to the PLC tag and check lah which memory is available. Okay. Go to PLC tag and check okay, which memory. So M0 already used, right? Okay. Or another way is okay. All these give a name. Right click here. Rename. All the tag to everything give name. Okay, what you do? You cancel. I want you to go up. Up some. Okay. I want to see both. Okay. Right click here. Right click. Okay. Rename. You move to this side. Okay. 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 So M01 is what? Okay, here. Okay. M00. Tag 1 is the SW1 P pass. Positive pass. Just rename. SW1. Just put P pass. Yes. Okay also. Then M02 is what? SW2 N pass. Okay, then tag 4 is the SW1N. SW1N. N, right? SW1N 0.3.
Yes.
Yeah, okay. Then tag 2. This one is what? SW2P. Yes. Okay. Change. Yes. Okay. Go down. Go down all the way. Okay. Now that number, right? Okay. What do you do? So you don't know what number want to use. Example. You can just type name also can. Okay. So this one is what? To off the LY1, right?
Yes.
Okay. Just put a name only. LY1 off. Off. Enter. Just enter. Okay. So what happened? Like this name only, right? Okay. Means it's an error lah, right? You right click it.
Right there.
Ask you to define tag. Okay, you click the define tag. Can you see? Automatically will give you a new memory, so you won't do a mistake. So like this also can, or you keep M0.4 also can. It's up to you lah. Okay, click define. Yes. Now use this to here, cut off the yes. You can copy, actually you can copy this.
And trade.
No, drag means it will move.
Oh.
So you can right click, copy. No, name.
Yeah.
You, if you want to copy, if you want to erase
Yeah.
everything on the name, you
Yeah.
can click on the address. Yes. Okay. Save, download, test. So now go down. Okay, turn on the switch click. Okay. My idea is I turn on the switch, the lamp on. After 10 seconds, I want it off.
But this one without S and R is that?
No SR, just normal output lah. Because this is cannot not SR because not same one. This program is similar to just now we do.
Oh,
Start,
okay.
auto on, I cut off. Only thing is I didn't latch it, right? Because my switch is like a continuous on, right? So I don't need to latch. Okay, so now what happened?
If push button then we do.
If push button of course lah. If push button or a memory that is like a pulse, it will do okay. Now what happened? Cannot off. Why?
Because it's a selector switch.
Number one, it's like the switch. Why? Because you see, very simple. The moment it's give the signal to here, this one will cut off this, correct? Actually, it's cut off. When this one cut off, the lamp will off. So here also will off. Then here will reset. When reset, this memory become off. So here, just now open, right? Normally close back. So this switch gives the signal back. So it's on, the lamp is on back. Okay. So now the problem is the switch. Correct. So, but it's a, let's assume it's a sensor. So we cannot off the sensor. But in the program we can modify, right? So what we do? Double click, change to pulse. Okay, good. So you don't know memory. Just put a name. Just put a name. SW3P. You can use this way. So SW3 space P. Enter. Okay. Rename. Define, right? Define. Okay. You can do this way also can, or you key M0.5, then rename also can.
There may be trigger of the pulse have to have
Different.
the memory.
Memory and different memory.
Okay.
Even you using the same one, the same SW, positive pulse, up and down. Here must have a different memory, up the different memory. Like this. Let's say the same SW2. And here got some another one. Same SW2P, right? Here must put 0.0, this one must be 0.1. Cannot be same. Even though it's the same SW2, same pulse. Yeah. You know, because what is the function of this? When this one from 0 become 1, right? Here give the pulse, right? Because here is the pulse. But the data of 1 must go here. So it will go here and kill. Okay? Now, in this case now, I already changed this to a pulse. Already solved the issue, but earlier I didn't latch because this is a selector switch. Now become pulse, right? So I latch it. I can latch. So we do one, I show another one, another way also can. Okay. test. Okay, right. So now you know the usage of pulse. Okay. So whenever you do program, of course normally we don't think of pulse, why not? We put normally open or normally close. So when you see the normally open is continuously giving signal, cannot off or cannot on something, then only we put into pulse. Because normally this one we don't straight away put pulse. We do a normally open, normally close. We test first, like just now. Just now like the set reset cannot reset, right? So both are on, and then only we change to pulse. Here also same. So when you put you put the normally open. Then test the timer. When the timer repeating, then only you put the pulse. So normally the pulse function you will do after you do some testing. Sometimes you don't straight away get the idea. Or sometimes you straight away when you write also you when you see also sometimes this one is always on. You put pulse. Sometimes you get the idea lah. Sometimes of course. Sometimes after test only you know. Okay. The set reset also is depend. Okay, depend. When you not all the time you need to use set reset. Okay, so even this program you can use this, right? Even I can use the set reset also can the same thing. But still need to use pulse lah. Go offline, I'll show you. So if I want to use set reset, this one uses the S. Okay, and this one the LY one you change to LY one, the output. The memory, remove the memory, change to the your output. Okay, then make it reset. Okay, then this one I don't need really. This one and the latch I don't need. Because the normally close I don't need, correct or not? Because I'm not using the memory. The latch no need because I'm using the set. So this program also is the same thing. Same like the previous one also. Okay? Try. you don't fix anything.
Oh, okay. For example, if like instead of the sensor, what kind of method for
Sensor or even the selector switch. Because some selector switch is like auto manual. So for auto, okay, you create a pulse, then make it like an auto function. Manual, then manual pulse, make it function. So anything we do here, right, we project or something, so don't fix, like, okay, start means normally open, stop means normally close, sensor means must use pulse, don't fix. Always think like input and output only. So it will be easier for you to do. And because based on my experience all this, because I also think, okay, usually start means normally open, stop means normally close. When I go to company and troubleshoot, because they use different kind of switches, right? Some like you press and hold switch. When you press again, then it stop. So different type. So what you do, you need to think like, okay, if the input on, okay, what I want to do. If the input off, what I want to do. Just think of input. Don't think of switch or sensor or that. So it will be easier. And programming logic, that logic is like telling story, you know. I press start, okay, I on the lamp. When the lamp is on, I run the timer. So when the timer is done, okay, I create a memory. When the memory is energized, okay, I cut off. And sometimes when it's not working, you just ask yourself a question. Okay, why not working? Why the lamp is not on? Why is set? You can solve the issue.
Just one question about the pulse.
About the pulse, yes.
I just want to understand. There's one of our machine. It's using the pulse.
Okay.
And it's usually an ejection system.
Okay, injection system.
So let's say we have cigarettes.
Okay.
Cigarettes moving here.
Mm-hmm.
And then the cigarettes it comes to an inspection area.
Okay.
So if the cigarettes without filter,
Okay.
it will detect.
Okay.
And then it goes to the shift register.
Okay.
And then like it, the shift register determines the injection position, but the pulse is coming from what's this? We call sort of like an encoder or
Oh, encoder. Okay. Okay.
so it's like
That is different. That is the pulse, right?
yes.
That is the we call high speed pulse.
Yes.
That is different. For that, we will be using the high speed counter. Remember yesterday we see the high speed counter, and for that we do use the high speed counter. So high speed counter means when it rotates, right? So you can get two data. One is the number of pulse, number of rotation. Another one is the RPM. So let's say this motor. Where is the motor? F the one encoder. Show you. So this one we will connect to this one. Then we will connect to our input. Let's say I want to use the input 0 as the pulse. not this P. This is a different. This is in the program. Okay. This P on N is because I'm getting a continuous on signal, so that is disturbing my logic. So I just want a pulse signal only. So I make it into one pulse only. Right. I turn on one pulse. I turn off one pulse. P and N. Okay. If this one is encoder means I need to in the configuration, okay, let's say 0, right? I need to enable 0 as a high speed counter. Okay. Then this one how many? Didn't show me one rotation is how many parts? Equal resolution. Okay. So once they give you, once you, I mean, it's not here. I mean, it's not showing here. Okay. But when you buy some others one, it show you what is the resolution. It means one complete rotation is 3000 pulse or 1000 pulse, for example. So when you connect this to here, so you already 0, right? So so this, for example, one complete rotation, right? So here must come 3000, it must show 3000. So when you rotate slowly, the value must increase. So normal input cannot do that. So when I configure this as a high speed counter, and they have a block for that, high speed counter block. Like I know you use block, right? For that they have a high speed counter block. I use that, then only you can get it. So what you just now say is that we're using encoder. So to know the position, right? To get the position. So what happened is, so is it what they have what conveyor system or what? The position.
It's the drums.
Oh, it's a drum.
Signal is moving through the drums.
Ah,
Drums.
okay. So the drums means of course a rotation, right? So they will rotate. So it will know. So what happened? It's not continuously giving the signal. Then another maybe another sensor lah. Detect there's no filter. You see. So detect no filter. So you know already. So let's say one whole rotation is 3000. Okay. Let's say at 5000. At 500, I detect the no filter. Okay. This guy send the. I mean when it's 500, there's no filter. No filter. The input on already. Right. Okay. So what I do? I use the 500. I inform those who do the injection. Okay. I inform. Okay. At 500, you need to eject. So there's another encoder. That one also will rotate. So go to 3000. After 3000 it becomes 0 lah, of course. Okay. Then go to 500. Then eject. Like a position. So that for what it means is, so they're using encoder for the parts function.
We learn in our course also.
No. This one cannot. This one additional lah. If you want to learn, this one can add on the advanced training. Because this one, if you want to learn encoder and you take 1 day.
PID.
Not PID, 1 day. 1 day to learn this. Because for this, the programming is very simple. But if you want to do program, you need to learn all these until the max function first. Max function first, then only you can understand this. And before you understand this, you need to understand the concept of encoder. Okay, here we will learn all these functions like counter, compare, everything. Then we will learn, so on the hardware side means we will learn PLC, we will learn the HMI, we will learn the analog with this motor, and we will learn for this motor. So we move to industrial motor controls, motor and analog controls.
Inverter also?
Yeah, this is the inverter. This is the inverter. Then this is also actually inverter, but normally they call VFD lah, variable frequency drive. Okay, so drive. So we will learn 2 drive. One drive using analog signal. So at the same time we will understand analog and also the motor. Then another one is using the communication. So anything other than that, okay, maybe you can come for another training. So because PLC is so wide, so big, so many controls. Like you said, okay, got high speed counter, okay, one control. Then
confused.
Yes.
Okay, one more question.
Okay.
When you select the timer,
Hmm.
it says,
No,
it shows manual and automatic.
okay, 想你去
Oh, the number.
Yeah.
The DB
它
number.
是它是哪个？
It's just to showing the DB number.
比如
So,
我只要开，其实 pause 我个人觉得很像不喜欢这样，它只是一次性的。
哎，
可是像我们用 switch 嘛，所以它是 continuous，
所以 DB
所以
right？
我要把 continuous
So it's
变
number
去
so
switch
automatic means
我就放一个 pause，
if you
就
see
说我弄一
which
次
number not
它
used,
变一次。
it will put the number here. 1 or 2, 3.
不过
If you
这
put
样子
manual,
做
then you can manually
就是
key
其
the
实刚才
number.
我就问了一个问题嘛，很像我讲我们没有放把它变成我们像那种那个开关。你
The
像
DB, not mistaken for this,
没有，就是你看台湾，
not mistaken, can go up to DB 1 until
应该是
DB 32766 or DB 65 655B4.
好，台湾哪就是好。
You can't remember. Just look at the
如果
S7.
I mean S 12一直给它跑，
是说我们不用去做，
就是 offline 这样子，它自己跑，就是它是 on 掉它跑。
对，
然后 R 是直接 off 掉这个，我们写 R 的话是直接把它 off 掉那个
S 的地方
S 就是 L 把 S 的那个地方。
对，
这样子讲的话，
那现在我们是用 switch 嘛，对不对？
所以
我们用
看
switch，
一下，比方说是
6553. Okay.
Done this before.
Yes, I've been doing a little about this. So
No, he know the basic because he work on the hardware and then he go and do some upload, download, do small changes. Okay. Any question?
Yes.
Yes.
So yeah.
Yes.
Do you try the PLC in your life, in your house, in anywhere?
No. I mean, I do projects like yes.
Okay.
Projects for company. In the house can put, but need to do a lot. You know, wiring, all that. Actually can control.
Yeah.
But nowadays they have separate home. I mean separate device for home automation. So you can use that. Which that one will be much more easier lah. Maybe I build my own something store something. I mean they can do lah. Yeah.
Since after this call coming in.
Yes, can use. Last time I have my one of my friend. He wanted to what? But I didn't involve. I give suggestion only lah. So it's like in a housing area. It's like a small taman. Okay. So they in front they have a security, right? So what the security want to know? They want to know if the porch light is on or not, something like that. A few signals they want to get from all the houses. So what happened is, I suggest them lah. I really involved. I suggest them after that they take my suggestion then they develop lah. Is there's a microcontroller called ESP32. It's a small, very small one. It's a microcontroller. It's using C language. programming. So I use that. I asked them to use that. Then they can use the LDR sensor, the light sensor, right? Okay. So put into each of the house. Okay. Because this ESP need power, need what? Need I think 5 volt, 5 or 20, 12 volt will be power up. Okay. Then you connect the sensor, and this ESP can use Wi-Fi to transmit signal. So then I use the Wi-Fi signal to transmit the signal to the guardhouse. So in the guardhouse, I use the PLC to get all the signals. Then I put an HMI. Then in the HMI, they can know, okay, this house LED light, the lamp is on. So in the night time, all they can know which house is the lamp is not on, and everything, some safety lah. Then they have all the security system. I mean the CCTV system, all that can do. But if you ask me for ours, it's not necessary lah, but we can do. Let's say last time my boss, his friend, he did something. He got a fish aquarium, big aquarium. So you see, whenever you go out, right, for vacation or something like that. So if in the fish aquarium, if the pump is off, how do you know? Suddenly the water pump, right? So if off, how do you know? You don't know, right?
For the fish.
Yes. So what happened is the fish will die, right? Okay. I mean the oxygen lah, right? Okay. So what happened is he put the power supply, the UPS. Okay. He put the UPS power supply. Then he put a 2 battery. Then from the battery they go to this one. Pump and everything lah. Okay. So now what happens? The signal from the battery connect to the PLC. The signal from the UPS connect to the PLC. So PLC can know. Okay, first the PLC will run the first pump lah. First pump, I think the first UPS or something lah can run that. If suddenly the first UPS cut off, then the other one can go. Something like that. Not sorry. If the main is not there, then the UPS will take over. So the oxygen pump is always continuously run. For that small system, we can use PLC. So PLC also need power supply. So the PLC always take the power from the main and also the UPS. Okay, go on. Okay.
So let's say this power in industry, mostly will be used at the sensor part, or which part will be used?
This
P.
that's why I said depend on, okay. Not only parts, even on the output also you can use. Okay, for example, see, when I start the motor 1 on, I latch it up. So motor 1 continuously on, okay. Then put motor 1, the timer. After the timer, a memory lah. I don't want to off this motor. I want to on this M0.0 to another motor 2. Then when motor 2, I want to cut off. Okay, so you see here, when I press start, motor on, right? Okay, so it continuously on. Then the motor 1 here on, okay, timer start. After the timer, this memory continuously on, correct? Because this one is still on, right? Here normally close. Now this memory on, continuously on the motor 2, then this one on. When the timer done, we will cut off this. Cut off this. Off this. And the memory off again. So what happened? Continue. Correct. Because this memory now is continuously on, same like just now. Right? So now what I do? Because why this timer is repeating? Because this memory is continuously on. This memory is from where? From here. This one is from where? From this one. Okay. Can I off the timer or not? Can, but need to off the motor. So unless I put some interlock here, maybe off the motor. But there's nothing to do. There's no signal to put as an interlock. So what I do? I change this into pulse at 0.5. So when this one is a pulse, of course, motor 2 I need to latch direct. So now, is it the sensor? No. Correct. Is it the what? Input? No. Is it the output? No. But still can use a pulse. So it depends on your logic. Depends on the situation. Okay. Here, from this signal, I'm on motor 2. So now I want to off motor 2. I use timer. Now the timer cannot cut off the motor 2. So what I do? Because of this. But before I put pulse, I try to off this timer. I try to think I didn't get any signal to off. So the only option is make it pulse. Unless this here can off, then I don't need pulse already. Because if I off this one with something else, right? With something else, so this memory will off. So can off already. So it's depends on the logic only. And later we do some projects, then we can understand better.
Then when to put M?
Depend. So I said, whatever question you ask me, I will always say depend. Depend on the program, project. In this case, okay.
Yeah.
When to put N?
Because that P is want to stop the M001, right?
Want to stop? No. P is because
Want to stop
earlier I get continuous signal, right?
Yeah.
To on motor 2.
Yeah.
I just need one pulse to on motor 2, not to off in this one. Earlier is continuous signal to on motor 2, so that I cannot cut off the motor 2. Now what I do, after I put P, now it becomes like pulse only.
But the motor 1 still running.
Motor 1.
Yeah, still running.
Motor 1 still running.
Still running.
Okay.
So that's
But the motor 2 not running, right?
okay. I mean after the time, after this memory give the pulse to motor 2, motor 2 will latch, right?
Okay.
Then
Motor 2 will run.
motor 2 run, then memory on. After this memory, of course, it will cut off.
Yeah.
Then it will put on,
Yeah.
finish. I will wait until someone go and off the motor 1. I press the motor 1 start again, then only can on again motor 2.
Okay.
Okay. So the end pulse. Where you want to use end pulse? Okay, for example,
Pass another switch.
I put stop. When I stop, I want to on motor 2. For example, right? Okay. So it means when the motor 1 off, I want to on motor 2. So I can use this. And motor 1, then on motor 3 and latch it.
On motor 2.
No, motor 2 is already on here. No. So I create my own shortcut. So it means when the motor 1 is off, then so it means it's not only the input can use as a pulse. Your output also can use as a pulse, your memory also can use as a pulse.
That means like if this kind of the design, right? When the M1 will stop, motor 1 will stop, then the M activate to on the M3.
Yes, correct. Okay, good.
PM0.0 is just want to stop that to.
No, not stop.
No, I mean after the timer.
After the timer, yes, of course.
I don't want to let it continuous.
Yes. So I just, the thing is, the idea is the before P, M0 is I giving continuous signal. Because of the continuous signal, I cannot off. So now I think I don't need continuous signal. I just need one pulse enough. Because I can latch it or I can use a set reset also can. So I just need a pulse enough. So you think that way. It's not, you think I use pulse because I want to off the motor 2. No, not that is, I use pulse not to off the motor 2. I use pulse, still I need to on the motor 2. Okay? But why I use pulse? Because one time enough. Because earlier is continuous so that I cannot off the motor.
I mean from this sequence is like after the timer direct off the motor 2, right? It won't continue run.
No, continue, no.
Then someone has to on it back.
Yeah, of course. So I stop the mode. So what happened? I stop this memory off, right?
Yeah.
So timer will reset. Again I press start, the motor on. The motor will on the timer. After the timer, this memory on the motor. So this motor one time on, motor 2 one time on, then close.
Oh.
Okay.
And
No, we do projects and you understand it.
Project in my hand.
Yes. The thing is, don't think of okay lah, of course, this one you try to understand the logic here, right? Logic, of course, you need to practice. The main thing is, you understand how the P work and why I use the P here.
yeah.
That's two things. That one you understand is okay. Logic you try to understand, can, okay, cannot, no problem. Practice.
Will we be learning this one?
Of course.
Don't come back to N.
Yes.
M1. Just now you said that M1 is stopped already, right? The motor 1 is stopped already, right?
Motor 1, okay.
Then the motor 3 will run back.
Yeah, when I press stop,
Yeah.
motor 1 will off.
Yeah.
So I use the end pulse to on the motor 3. Means I press stop. So in that case, I don't need this also. I even can use the stop button to on the motor 3 also, okay?
But I need to make it auto, so that's why I need to put the M there.
Okay.
Okay.
Mr. Tim, can I say that let's say we're using the N. Okay, because let's say stop is 0, running is 1. This one is for P. But for N, running is 0, stop is 1. Can I say?
No, don't use that word.
Yes, the one.
The thing is very simple. You just don't complicate. That's why I say, don't try to come to like one point. Okay, this is this. No, try to understand the concept, how it works. That will be easier because very simple. I have P and also the N, right?
Yes.
How it works? When this one from 0 become 1, right?
Yes.
I give the pulse. That's all. N means this tag here, right? From 1 become 0. I give the pulse. That's all.
Okay.
That's all.
Okay.
You got it? No.
I don't know. What you declare the power is?
Pulse. Means I just is pulse means on off.
Pulse is on and off.
Pulse is on off.
Okay.
It just give you a signal that is on off. That's all. That is the pulse signal. But when I give the pulse, that is the matter. P means from 0 become 1, I give the pulse. N means from 1 become 0, I give the pulse.
Open give a pulse, close give a pulse. Cannot say that this way.
No.
You still send 0110.
No.
That is easier.
Mm.
Means, okay, past, how to say, means here, okay, very simple lah. Here, so when from 0 become 1, right?
Mm.
This line, from 0 become 1, then become 0 back. Correct?
Mm.
Initially 0, right?
Yes.
Then become 1, then become 0 back.
One time. Yes.
One time, correct? Here's the same thing. Here, when initially 0, when the this tag here from 1 becomes 0, then 1 becomes 0. That is a pulse. This is the pulse. This is what means the pulse function. One pulse. Like one time signal, on off. That's all. Like a push button.
You just want to activate something. Just chop.
Yes. So at the end, can be anything. Can be a timer, can be a coil, can be a set reset. Maybe learn some other functions, can be any functions.
Just be
Which one you confused?
P and M.
P and N. What you confused?
Okay, because why? Just a question only. Because like as you said, we no need to set a P for what and for right? At least I need to know how to play the P and M.
Okay, the thing is, when I need the signal.
If let's say
Okay, where?
let's say we call it sensor sensor.
Yeah.
Make it easier lah.
Yeah.
When I detected right, that means I need a signal.
Okay, correct.
When not detected, I also need a signal.
Yes, correct.
Okay.
So, I use sensor lah.
Okay,
Sensor one.
Sensor two.
Same sensor.
Okay.
Okay. When the sensor is detect,
Yeah.
what I want to do? Maybe I want to
Do something.
do something
Maybe
on the pump.
On the pump.
On the pump.
Yeah.
Okay. Let's say you set lah.
Mm.
Because I mean it's a pulse, right?
Yeah.
So I will on the pump.
Yeah.
That's all. Okay. Then when the sensor is
Not detected.
Not detected. Off.
Off. Yeah, it's off.
When it's off,
Yeah.
I want to on the conveyor.
Can I off the pump? We call it
Of course
off
can.
the pump.
Of course can.
Okay.
Of course can. But instead of using this, I might use this one as one pump. Because when on, pump on, when off, pump off.
Yeah, that's right.
Correct.
Is something like this?
So, I mean, of course, like, if it is the same, if you want to control the same thing, of course, okay, I better do like this. If I'm controlling a different things,
Okay.
then yes, I can on this.
Like for example, P detect, on. The pump one will on, and N is like as you said, not detected or something lah, feedback lah. Then the
It's not feedback. It's already detected.
mm,
Then off. Then only N can give signal. You know, it's not like not detected. You detect already.
yeah.
Then it's off. Then only the N can give pulse.
Okay, if let's say like this the N after the N, maybe we can on pump two, but I need to off the pump one.
Off the pump one and on pump two.
Yep.
Can. Indeed. So I reset pump one and set pump two. Okay.
Like this. Let me try.
Yes.
Yes. Yes, correct.
Basically, I would say it's a memory.
Mm-hmm.
The memory I'm using the next line. Next line.
Mm-hmm.
This one is considered as a
Contact, must use contact.
contact.
Always in front must use contacts. Normally open or normally close.
Then let's say after this one coil, can we still add some,
Cannot.
you know, so
If
this
you
one is
put
the-
coil,
Mm.
then if you want to put another coil, maybe down here.
Okay.
Yes. The last one is the coil.
Okay.
Okay?
So let's say after this one,
Mm-hmm.
I know
Mm-hmm.
we can don't want to add any.
Can.
No problem.
What is it?
Uh,
Don't want to add anything.
yes, I don't want to add any memory. Just until here can also.
Can. But the timer will just run lah. So what I want to do use for the timer.
So it will keep.
Because why we put timer? Because we put timer so that after the timer I can use the timer output to do something.
Let's say after that, I will close it. So I don't need to add anything.
Can also.
Can also.
Okay.
Go back to the now the P and N. That follow this concept, right? When we push the P, I mean the S1, we pump one will run. But when we release, the pump one also will release, but not. Okay. Same also.
Yeah.
Same. They mean the pump two unable to release. See, I follow the method like S1.
You go up.
Well, have to delete all.
Yes.
Okay.
Not delete all. Make sure no clashing.
Okay.
No. Okay. Which one you want to delete? First thing.
Because I need to run, let's run this.
Okay. You want to? No.
Okay.
Okay. This is the one. Input no multiple time I use not issue lah. Okay.
Okay.
Output here R1, R2. Okay. Go up. Where I use R1.
Here, up to.
R2. Okay. Go up. Then of course you need to delete network 1.
Delete.
Delete. Yes. Network. This one also delete. Yes. Delete. Yes. Because if I repeating the output, I cannot work.
Oh,
Okay.
exactly. Oh.
we start?
1 hour. 2 o'clock.
2.
Yeah. Come early also no, not an issue. Because I go buy food, then I will be here only.
We will just downstairs here.
Oh, I want to go have lunch there.
你了解吗？
我看你不了解，我在想住，我在想住。
对啊，我是在想，到底是怎么处理？
Okay.
OK。
Go for lunch. Because I need to go buy food. No needs for me, no problem. Yeah, you didn't bring food. Yes. Makan ready?
Yeah. Ready. Later you do one more time the manual, I mean the testing for this
Parts.
mouse
Yeah, sure.
PNRS also one more time. I
Sure.
really confused. Cái tụ kỳ nhiều quá. sesuai dengan belakang mesin.
Ya,
可以吗？
try 哦。
没有，我那边一直哇。我想要的土包。
那找很久。
因为刚才我跟他讲，再解释多一次。
哦。
因为那个包上面真的有点 confuse。R 跟那个 S 跟 R 一定要在一起，可是 B 跟 N 不一定要在一起的。
是啊。不一定在讲。这是真的。
所以我就是我讲，等下再讲清楚一点。没有，我就很，
就是要试看哦。
就是说至少给一个 example 啊。
对。
就是说那个 SI 会可以在一起啦，只是那个 P 可能不需要网络，对不对？
对对。
Next week I will get to that's the keys. Keys here.
Why after the program, right, I on this button, right, and I delete the network, but the light still on.
Did you download already?
Huh?
Did you download already?
Download already. Still this I download. We download, right? Done. The light still on.
Which light is on now?
Huh?
Which light is on?
1, 2, 3, 4, 5. I 04.
0, 4. Okay, what you do?
Yeah.
You stop.
Stop.
Yes.
Okay. Oh, stop already.
Run back.
Alright.
Yeah.
Oh.
Because what happened, just now previous program you downloaded, right? So I think it's a latch or set program. So the value is already set. So you download new program. So it's the new file is there, but the set value 1, right, is always there.
So that's why the lights keep on.
Okay. Now, pulse function. Okay, pulse function is
Make it separate, pulse and can. You get what I mean?
okay, because I know because you confuse P and P is pulse. No. P means it's a positive pulse.
Yeah.
N means it's a negative pulse. It means it's not like positive means the line is on, is positive. No. I detect a positive signal, I give pulse.
That means the line is 0, then detector become 1.
Not the line. Not the line. The S1. Let's say this, I put a boolean. A boolean, we talk about boolean. I put a boolean here. If the boolean from 0 become 1, so the P. So P only will detect from 0 become 1 only. So when the P detect this boolean from 0 become 1, here I just give one on off. That's what I normally call pulse. I just give a on off signal, that's all. Understand? No.
I understand.
Okay.
How about N?
Okay, no, wait.
Okay.
This one understand?
Understand.
Okay, how it works, let me show.
Like for example, we call it like we call it now like the button. Because just like I try already, if you have press the button, right, that means have a signal from 0 to 1.
Yes.
So the pump will on.
Yes.
Then the pump will always on.
Mm.
After you release the hand also, the pump will always on, right?
That one is because of the set. That one we don't care.
Yeah.
Okay.
Then if like P without the set, right? Same like the normal lah. The normally close at NC and then O lah.
Yeah.
Like and O like when we press, normally they will detect it lah. Release, no detector already.
Okay.
Okay. This is why I know for the P.
No, still not there.
Not there.
Because normally open sensor 1, let's say the pump, right? Okay. And let's say I take out this one. Okay. Normally open button. When I press, when this one become 1,
Yeah.
I give continuous signal.
Yep.
If I take out, I off.
Yep.
This one, how long I on also, I just give one pulse. Means just one on off, that's all. Finish.
Okay. Then the pump will run.
No, it won't run.
It won't
Because
run.
I'm just using a coil. Cannot run.
Okay.
Unless I use set, unless I latch it. You understand or not? Here, how it works, you know. When the sensor become 1, here the line will on and off again immediately within milliseconds.
Okay.
That's what we call pulse. Like a push button, you press and take out, right? That is the signal.
But it's faster than 1 second.
Yes, faster.
Okay.
Okay?
Okay.
This one is from 0 become 1. Okay?
Yep.
Here, from 1 become 0, I give one pulse, I off. That's all.
Example.
No example. You understand this or not? No need example. What we need to take, I take out this one. I don't care what is there. The first thing is you need to understand the pulse, how the pulse works. That's all. So when sensor 1 from 0 become 1, I just give one pulse on off, that's all. Finish.
Right.
N means N will detect If from 1.0, from 1 to 0, then I give pulse. P means it will detect from 0 to 1. If it is from 1 to 0, it won't detect.
They mean is like P is a detect. Oh, no.
Both are detect.
So I detect, but different.
Different values to
Yeah,
detect.
one is like I need start from 0 to 1.
Yes.
Another one I need to start from 1 to 0.
Yes.
Okay.
Then I just give pulse, that's all. Here I don't care what I use. Here I can put a timer, here I can put a set, reset, and can put anything. The main thing is you need to understand it is the when to use. So now when to use.
Okay.
Now I have a sensor. The process is if the sensor is on, I want to on pump number 1.
Okay.
For example. So I put the pump. Okay. Since this is a pulse, of course the coil cannot keep the value. So I have two choices. One, latch or using set.
Okay.
Let's say we want to use set. Set means I don't need to latch. That's all. Okay. So that is the first condition. Then the second condition is when the sensor is off, I want to on pump number 2. You don't care what happened to pump number 1. We don't care.
Yeah.
Maybe got timer or something. Okay.
Okay.
So when the same sensor, when it's off, I want to on pump number 2. So see whether it's a set or latch is up to the program.
Okay.
I can even latch also. Okay, no problem. So don't care who off this one. No.
Okay. How about the R?
What are?
You mean the S and R, right?
Okay. If S, so
Now I understand.
because I think you combine both R, S, P and N, combine both. No.
Yeah.
This is different, this is different.
Okay.
Now you understand the pulse
Yeah.
function? Okay?
Yeah.
Pulse is different. Okay. Now we go to the set reset. Set reset is very simple. Set reset is I have one signal, let's say push button. Okay?
Okay.
I have a push button. I want to on a say pump for example. Okay. Pump. This is different. In that way, no. I put motor and use one piece. Okay. This is a push button. When press the motor on, when I release the motor off.
Yep.
But my process is not like that. My process is I press, I release, and I want the motor continuously run.
Yep.
So it's up to me. I can use this latch, or another way is same PB setting.
Okay.
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 Now, in this case, so now I PB1 lah push button. Now I have another push button. When I press, I want to off this motor.
Okay.
If I do the program this way lah. So in this case, what I do, I back up.
Yeah.
In this case, what I do, I need to reset. Because I can off this. Because this one, this guy, when I press, it's already give the signal, then off already one. So there's no point I put a normally close here.
Okay.
So how to off if a output or memory I already set by reset the same.
They mean the motor can, the output can be used. Both.
That is, yeah, of course.
But the
Top one means very simple. If you use set, if you want to off, must use reset.
Okay.
That's all.
Okay.
If you use coil, if you want to off, you must use this.
Yeah. They need someone to off it.
Someone to cut off it.
Okay.
Okay?
This one.
That's it. Because I think from just now you try to combine both set reset dengan pulse. That's why I think confused. Different.
Okay.
This is different. This is different. Because why I use for the pulse, I use the set reset for easy understanding. That's why.
Oh, can we say this way lah? If we play the P and N, right? We play on the sensor, I mean there is no issue, right? Like for example, as you said, PMP and PM, right? It's always on or always off. If something detected, they will on. That means there's a P. So the P, the pulse will give the signal to that. Then after that they off already, but the signal there already on.
Yeah.
If it's whole way lah, I mean put the S lah. Like another one sensor is always on, when detect something is off.
Off, yes.
Then we need to on another one something.
Yes,
It's always on that.
Yes.
In if let's say we can play this way, like for example N, right? This is one sensor, is an N, always on, right? N is always on. Always on, we will on the pump 1. And detected to 0, the pump 1 will be off on the pump 2.
Can also.
Some sort of this, right?
Can.
That means the P and N is separate, is different.
Yeah, it's a different.
If let's say for example, how to make it like now we make it P like P first P detect only on 1, non-detect the pump 1 will be off on the pump 2. If let's say this kind of thing, how to do it?
Okay. No. We don't talk about P or N.
No, only
The sensor.
Only the
Okay.
sensor.
When the sensor detect,
Detect the pump 1,
pump on.
on.
Okay.
Non-detect pump 2 on, the pump 1 off.
But because you see it's always like this. Either, so what you mean is when the sensor detect, okay, I on the pump 1.
Yep.
When it's not detect, I on the
Pump 2.
pump 2. That's off the pump 1.
Yep, right.
But initially you need to detect first, correct or not?
Yep, right.
Detect first, then when it's off, then only I jump lah, right?
Yep.
So the same thing.
Don't end lah, end don't just erase the end lah. We just only for the P first.
Okay. So when the sensor detect,
Yeah.
okay, that's all enough. This is the memory here. Enough.
Yeah. Enough. Then when after if the pulse, right? No. Then how to stop the pump one? Non-detect, the pump one have to stop, but on the pump 2.
Okay, that's what I said. You must give me the flow.
Okay.
Okay, first flow is what? When the sensor detect, the pump is on.
Yeah.
That's the first flow.
Yeah.
Okay, second flow. When the sensor is not detect,
On the pump 2, off the pump 1.
then when the sensor is not it's not like not detect, the sensor is off.
It's off, yes, right?
Yes.
Off.
So when the sensor is off, but it must on first.
Yeah.
Then only can go to off, right?
Yeah.
So when I on the pump. When the sensor is off, I off the pump 1
Okay.
and pump 1 and on the pump 2.
And on the pump 2.
That's what you told me, right?
Yeah.
Ah.
Then after that, if the detect and go back to the pump 1.
Which one not? Which one? Now which one?
Now you see, now the pump 2 run already.
Now you can. So you need to imagine. The problem is
Yeah.
you need to imagine. Okay, now sensor is off.
Yeah.
You on the sensor. Okay,
Yeah.
let's say. Okay, something else. Okay, come here. Sensor detect.
Yeah.
Pump on.
Yeah.
Water is filling.
Yeah.
Okay, once finished, it goes.
Yeah.
It's off.
Yeah.
When it's off, another pump on.
Yeah.
Doing some other function.
Yeah.
Then what do you do?
Continue the detect again.
So when the sensor detect,
Again.
okay, again.
Then pump 1 run back, the pump 2 stop.
Okay. So when I detect again,
Yeah.
pump 1 on back,
Yeah.
pump 2 need to stop, right?
Yeah.
Is it the pump 1? So the condition is
Okay.
When sensor detect, pump 1 on, pump 2 off.
Okay.
When sensor is off, pump 2 on, pump 1 off. That's all.
Right. Can.
You okay?
Thinking one question.
Okay.
Normally, let's say we click on the P or N.
Mm-hmm.
Okay. Then, like this one. Okay. This part.
Okay.
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 Before it's originally this one.
Okay.
Let's say we're doing the P.
Okay.
Okay.
Mm.
This part,
Mm.
we need to link to this one. Or we need
No. Of always,
Mm.
when using a pulse, must use a new memory.
If let's say we link this one together, what will be happen?
It won't work.
Oh, okay.
So always the pulse. Okay, why I need this? It's not linking.
Mm.
You need to understand what is the function of this down here.
Mm.
The function of this is cannot use this. Must use different.
Okay.
Okay.
Mm.
Why? Because
Mm.
when this one on, right?
Mm.
Here it's normally open. What is the function of normally open? When I detect from 0 to 1, I continuously give signal.
Mm.
Yeah.
So when I use pulse,
Mm.
but the detect the value 1, where to go? I need to store somewhere. So to store the value here.
Mm.
So the value of 1, if you store here, and here I just give 1 pulse only. So that's why here I must use a different memory. Cannot use this one. Okay, that is number one. Number two is this timer won't work. Why?
Because
You don't have power to do the timer.
Yes, because the timer need continuously on signal. Very simple lah. And
yes.
and the input I need one
Mm.
to run. So if I zero, I won't run.
It's like
Let's say,
yeah,
let's say this way, okay, we put in the S behind. So, timer will be function?
No,
Also no.
no. Timer need input, right? Timer need input, right?
Yeah, but now this one I feel.
No, you forget about the set. Forget about the output, the Q. Timer first, I need the input
Yes.
to start function.
Mm.
The input must be continuously on.
Okay.
So if the input is not a continuous on, if the input is a pulse,
Mm.
so I cannot even do the timer job. I cannot even do the timer calculating. So how am I going to on the output? So always output is nothing.
Okay.
Here I can put anything. This one you always think like this is like a PLC lah.
Mm.
I give input, I have output. So this PLC, for example, this PLC, the input must be always run. Then only I can give the output.
Okay.
If the input is pulse, so the timer is not even cannot start, so I cannot give the output.
Okay.
Okay, good. Good.
Okay, I understand.
Understand, huh?
That means that's why PLC I was confused. Now they mean right in our PLC right. I just example no matter how we use the Siemens or the sensor we buy right, either PNP or NPN.
Yes.
We just set from here only. If let's say it's an NPN right, that means detector.
No.
No. The NPN is different. NPN is like 010.
No, don't confuse with NPN PLP. NPN PLP is the type of the sensor.
Okay.
Whether it's the NPN or whether it's the PLC, the sensor, my PLC going to read 1 or 0 only.
Yeah, correct.
Okay?
Okay.
NPN or PNP is the signal I receive.
Yeah. Input right.
The input I receive. If NPN, I receive 0 volt.
Yeah.
That's all.
Then
It's different.
Yeah. PNP is
PNP, I receive
24.
24. That's all. Even NPN or PNP, if I send signal, the PLC going to be still 1 only.
Yeah.
It's not PNP send signal, I become 1. No. PNP or NPN send signal, I become 1.
Okay.
So-
So it have to depend on the last
Not
yesterday.
depend.
No. Yeah, yesterday we discussed. We practice right.
PNP
Depend
or
on the it depend on the M.
M.
Is a 24 or 0?
0 volt. Then I decide PNP or NPN. That is a sensor. That is a, they call my field device.
Yeah.
My field device, nothing to do with my program.
Is based on your 24
Yes,
or
it
0.
depends on the sensors we buy.
If you put 0, that means is NPN. If 24 is PNP.
Yes. That's all.
Okay, it's separate.
It's separate.
Okay.
Okay, good.
Okay.
Okay, good. Okay, now we do one project. you do a project. So we already learned set, reset, pulse, and okay. So we put day 2 project 1.
Day 2 project 1.
Yes. Day 2 project 1, then you create, you add a new PLC and you leave it first.
Day 1, day 2.
Yeah. Okay, good. Yeah?
Mm.
Okay. Now, so we don't do any program for that. I will show you how to, from the flow chart, I will give you the flow chart. From the flow chart, how to create a program. Okay, we learn this. So this flow chart they call graph set. Okay, so we have two symbols. That is, one is the condition, one is the function. Condition means okay, whatever. Sensor detect, push button press, temperature high, detect, sensor is off, what I do, sensor on, what I do. Okay. Function is what I do. So let's say like just now, like you said, what? Sensor is on, pump on. So sensor on, pump on. Sensor off, pump off. Something like that. Okay. So let's say I do first I do a simple one. When I start, motor 1 on. At the same time, I on a timer. 10 seconds. Okay, when the timer is finished, timer queue lah, timer done. Okay. Then motor 1 off, motor 2 on. Okay. Then when I press stop, motor 1 off, motor 2 off. Okay. So when I press start, motor 1, at the same time timer run. When timer is finished the job, I want to off the motor 1. The same timer on motor 2. When I press stop, means it's not like it's not sequence like 1, 2, 3. No. This is the condition. The function is two functions. The first one I need to off, then the same timer must on motor 2. Same here. The same stop button, off motor 1 and off motor 2. Okay, I press start. Motor 1. That's all. Okay? That's what they tell you, right? According to this until here. Okay? But when you do testing, you need to latch. Correct? Because it's a push button. I latch it. Because in your flow chart, they won't tell you. You need to latch, you need to use pulse, they won't tell you. When we do testing, then we need. Okay? finish. Then the same start button on the timer. Start button on the timer. 10 seconds. But can start button run the timer? Cannot run because it's a push button. If I want to run, I need to continuously press. So what I do? But according to this, start on, right? Okay, what I do? So when I start, what happen? Motor on, right? Means this and this on at the same time. So I use the motor. Unless they give you another one, maybe use another one. Depend on our flowchart. Okay. Timer on ready. Now, like you said just now, you just now asked me like, do I need to add something here on, right? It's depend. Now, from the timer will give me one output. From the output, I want to off motor, right? Actually, here you put name, right? Timer 1, correct? Actually, you can use this here. Timer 1.q can use also. Okay? But if I want to on something else, another one, I cannot use this one because too fast. Too fast means the moment the queue is on, it will cut off the motor. So I cannot use the timer here because too fast. So instead of using this, that's why I straight away ask you to use the memory. So I take memory M0.0. So M0.0 means this one. Right. Now what I need to do? Once the timer is done, motor 1 off. I use this to hit. The same timer, motor 2 need to on. So I use this. Okay, this one do I need to latch? Okay, sometimes we cannot. Sometimes we cannot imagine. Then download, test. If can latch, if it is can continuously on, leave it. If cannot on, but you know the memory is already on. Because how I know? Because here cut off already one. Then you latch it. Then you try again. Is it correct or not? Or is it I put normally open, not working. I latch, not working. Oh, maybe normally close. Because the contact you cannot predict. Sometimes you cannot predict that. Okay. So right. Now stop. Need to off the motor 1. So motor 2. Okay. So you see how I do program. Actually, according to this, I know already. I put start, put latch. Put the stop, put the motor, I latch. But I didn't do that way. I put start, motor first, and I latch it. Then I use the motor timer. Once the timer finish, put the memory. And I use memory to cut off this, to put here. Then on the motor, I latch it. Then only I add the stop button. So that is how this, when you write a program, if you follow this sequence, it's easy to write a program. Okay? Okay? Any mistake? Okay. Okay, Moses? Can? Sleep? Okay. I want to erase this one. I want to take picture, can take picture. I want to erase, I want to do a project. Okay, good. Okay, now I erase this one. Okay, there's no programming here. We do project. Okay, don't do any programming. Okay. This one is something similar to what we do yesterday, right? But with a proper like a project. Okay. I always use this as my first project. Okay. So it's a tank. I have a tank. Okay. Small tank. Okay. Then I have a valve one. Okay. Fill in. Then I will mix and also a pump to pump up. So very simple. I fill in, this one I fill in, once I reach certain value, then I mix, then after that I pump out. Okay? So this is valve A, this is valve B, this is mixer, this is the pump. Okay? Now, normally tank will have a level meter, right? So level meter is analog, right? Because it will give you value. So we have any analog here. So what I do, I put two level switch lah, okay? Float switch lah, for example. Then this is the high level, this is the low level. Then we have a start button and also a stop button. Okay, start button, stop button. First we see how it works. Then I will list down the I/O and also I will do the flowchart. Now, how it works? When I press start, I start to fill lah. Okay. Then I start to fill until the low level. So we don't have actual tank, right? So what we do, we use this. Just imagine we can. So just imagine, okay, already reached low level. Use the selector switch, right? We just on the switch. Leave it on. So we use that as a low level. Leave it on. Then when I'm on, I want to stop exactly here. So from this level until here, I want to put a timer. Because we don't have a level meter. We are using this. Then we use a timer lah. We assume the flow of the valve is a constant. It's the same. So we can play with the timer. Stop here. Then once I reach 10 seconds, I'm off the valve A. I'm on the valve B. Then start to fill until the high level. Okay. So just imagine. Okay, after valve B is on, just imagine already reached the high, okay, on the high level. When you hot high level, the valve B off, mixer on, mixer run for let's say 15 seconds. This timer you can play, no problem. It's up to you. Want to increase or want to decrease, sometimes you already done, so you know how it works. Okay, put small timer. But if you want to see, cannot see properly very fast, put big timers. No issue. Okay. Then after 15 seconds, mixer will off, pump will on. Then pump will, the level will decrease. So first high level off, right? So you off the high level. Then you leave it. Once you go down until here, okay, off the low level. Then it's okay. Okay?
You want the low level pump stop.
Pump stop. Okay? So we don't just ignore this one lah. Okay, don't get. I can put some timer or that, but I don't want to make it complicated. Make it simple program, so make you understand. For me, I want you to understand the flowchart. Okay? So whenever we had a project like this, first thing is the I/O list always. Okay. So we have start button, stop button, low level, high level. Okay. Start button, we have a push button, right? So we use the I0.0, I0.1. Okay. Then low level, high level, we use the selector switch. So the third push button we don't use that. Maybe for other project we can use. So this should be I0.3, I0.4. Okay. 2 we cannot use. For output, valve A, valve B, mixer, pump. Okay. So valve A is, you can use any lamp, right? Because it's not connected to any valves, so no issue. Okay. Now, when I press start, valve A on. Okay. Press start, valve A on. Then, when low level is on, because valve A on means it will increase until here, right? Low level on, I want to on a timer VA 10 seconds. Okay, so it will reach until here. So when the timer VA is already done, already finished, valve A must off, valve B must on, right? So valve A off, valve B on. Okay. Then when valve B on, the level will increase. Okay. So the low level, high level, you need to manually do. So just imagine, okay, already go up, okay, on the low, high level. So when high level is on, off the valve B on mixer. So valve B off, mixer on. Okay. Then mixer run for 10 seconds. So at the same time the timer on. So timer mixer 15 seconds. So if timer mixer is done, mixer off, the pump on. Okay, mixer off the pump. So when the pump will off, when low level, first high level, when high level and low level both off, the pump also off. Finish one cycle. Want to return, later we do. Okay, want to repeat, later we do. Okay, so for stop button, when I press stop, valve A, valve B, mixer, pump, all off. Okay, so like this is stop lah. Just press all off. So later we can modify. Okay, when you want to do this program, don't do everything then test. Difficult. You do one by one. Okay, when you do the start valve A on. For the valve A, you add the stop also. Then you try working on, working. Then continue. Okay, when low level on, timer. After the timer, valve A off. Okay, you stop until here. Test from the start. Can work on. Then okay. Then when valve B on, high level, valve B off. So every time one output on off, okay, you stop. Then test again. Test and see. From here, test and see. Then when the mixer on, timer, after the timer, mixer off. Yes. So if you do like this, it will be easier to do program at the same time troubleshooting. Okay? Okay.
So, what is this meaning after default? After first name, code.
Error.
Yes, error.
Okay.
When I see the error, I see the error.
Assignment or picture.
Oh, oh.
Yes. What do you mean? Record or assignment is required.
Oh, yeah, wrong.
Yes.
Oh, actually, oh, okay. Then this one we create this one is for.
No, question mark means if you tell what is the error meaning.
Oh, okay.
The error is go to.
Ah, thank you.
Go boss. Okay.
Let's try later.
Very slowly, it's okay.
Yes.
Go down there, so maybe go to the chicken machine. Going to be rain every day, rainy season for me. Yeah, okay.
acting like this. Okay, come. Now I do this way. I all format the recipe one, but I need to see how to apply the R and S because this one got internal, right? The sensor. For this program, how to make it? Now I use very simple.
Okay, go up. Go up. Okay, wait, wait, I want to see. Go up. Okay, go down. Okay, go down. No, go up. Okay. Okay. Go down. That's the pump. Okay. Oh, you give timer for pump also.
Clean also lah, that means still have some balance, right? That mean like if let's say this right, from the LL, that mean low level, high level. There is a request of what detect, as I mentioned the level, detect or non-detect. Is it the is the N or is the P or no? It's not a pulse, right?
Not necessarily pass. Pass not necessarily.
Here's a like sensor. At least they have the feedback. One detect is coming, another one sensor.
Yeah, yeah.
If non-detect, that means no current.
Yes.
If it from this
So
way
this
out,
one can also.
this selector or so I do adjust. If another one side, that means make the pump force to off lah.
Yeah. Okay, now when you test and see. Go up.
Okay.
But it's working, right?
Yeah.
Okay, start.
Start.
Okay, low level on.
Low level on. I put 10 seconds lah.
Yeah, low level on.
Then the valve will close off.
Okay, go
Then the
down.
valve B will on off.
Okay, go down.
Then after that wait for the high level.
Okay.
So the high level I put the pulse here lah.
Okay. High level on.
On. Then the valve will off. The mixer will on. But on after 5 seconds.
Mixer off.
Off. Pump on.
Okay.
Then pump on. They will continue to all the pump lah.
Okay. High level off.
High level off. Still continue the pump. Pump until
Low level off.
low level off. Then timer on. On 5 seconds. Pump off.
Off. Okay. Go up.
Go up.
Go up again.
Go up.
Why this one still on?
This one I just how to make it lah.
So this one. Okay. Why I need this memory? This memory to on the mixer, right?
Yes, correct.
And to run the timer, correct?
Yes,
After
correct.
that, I don't need, correct?
Yes, correct.
Then can use this memory to off this.
Can also
Yeah, that's how I do.
mixer off.
Go down. Yes, that's all.
This is mixer off.
Mm.
So that means like mixer off. Mixer off, that means the pump will off again. Try. Stop all. Start.
Actually, this one actually no need.
This one no need ah.
No need. But never mind.
Later lah. So I on the bar.
High level.
So run the timer lah. So after running timer, pump the run.
Okay.
After run,
High level.
high level off,
Low level.
low level also off.
Okay. Now go up.
Well, here no need.
Here you see it's still on, right?
Yeah.
Actually I don't need one. I don't need to latch because if no, I need to stop this because the next time timer can run.
Oh.
Can run. Now all finished already, right?
Yeah.
Now you press start.
Yeah. Still running.
Yes.
That means this one I need to.
No, not really.
So that means here don't have any powerful. Once I make use one, I mean detect the level.
Yep.
Then the SNR.
See this stop no need already.
Stop no need.
Because just now you latch it, that's why you put stop.
Yeah, right.
So no need.
No need. Right.
Okay, go down.
Down.
Okay, stop is okay. Okay, go down.
Down.
Okay, actually this stop also actually no need. You know why? Because
Mixer off.
no, not because this one. Because when you stop this, this one will off, right?
Yeah.
So if this one off, this one also will off.
Okay.
So here also will off. So it will off the mixer.
Oh, okay.
So not necessary.
Now,
And this stop won't function. You know why? Because after the timer, if the queue is on, it will always on only.
okay.
Cannot off, cannot stop.
Okay.
Unless you put some latching, then it's okay. Like just now the earlier one.
Then have to run. If latching, then have to put a stop.
Yes.
If without latching,
Without latching for a timer, it's like it won't work then.
yeah, because the mixer
Because
won't work already.
when you stop, mixer off, so here also off.
yeah,
so no need.
already. So no need already.
For the pump, this one it won't work
Okay.
because
I force it to off.
yes. So if you want to off the pump, I mean without this one if you want to off the pump,
Maybe I need to come
put the
out.
stop there.
Put the stop here.
Yes.
Okay. any SR, RN or something, right?
Set reset.
Mm.
If you not necessarily want to use. What you also can use. It's up to you. You already done already, right? Maybe try to use one output as, because all the output use coil, right?
Yeah, yeah, yeah.
So you try to use maybe one output as a set reset.
Set mean like on. Reset means
One
someone
off.
off.
Yes. Only you take one output. Don't do for all.
Yeah.
Maybe okay. Let's say I want to do for pump, okay, use pump. Or want to do for mixer, do mixer. Want to do for start, I mean the valve A. Only one.
They mean something is on, they always on. It's R for the pump is like need to be set up. Off.
Yes.
Okay.
Hmm?
So actually to ask for you.
Try and see. Right? Pump.
Pump, right? No, wait. This is pump. This.
Okay. So if this one, then I don't need this, don't need this, don't need latch.
Okay. This one also don't need.
So if I stop, how?
Stop.
I need to reset.
Yeah.
Correct?
Yeah.
So here I have a reset, right? So put the stop branch here.
Branch.
Yes, open, normally open.
Okay, open.
Okay, this one after left, no, not that. After drag and yes.
So here you put stop.
Yes. So when this memory on, so actually instead of in this one, the S straight away I can put here also.
Here also you put.
I mean instead of this using this
But
memory.
this one is memory room.
But not necessarily what?
Oh, they mean not necessarily to put.
The memory because after the time.
Oh.
I understand?
Understand?
Ah,
That
but-
means I take out the pump, the memory, all the S I put there.
Yes. But don't do that. Never mind.
Don't one by one.
No. I mean leave it this way.
Okay.
So you try it.
At least do something more.
So when you refer, so you know you use normal coil, set reset coil,
Yeah.
pulse function, time also. Whatever you learn here, you already apply here.
Yeah.
The most important, the logic is working. It's not the it's not.
Okay.
You know how to use the pulse. You know how to use the timer. That is the important thing. So now you see, now you're familiar with the software.
Okay.
You know how to download.
Okay.
Okay. Tomorrow we do upload again one more time. Okay.
Okay.
Then you know how to do tagging.
Okay.
You know how to use the memory.
Mhm.
That is important.
If I
No,
Okay.
I can't switch off my mixer. I don't know why.
Never mind, no problem.
Yes.
No problem.
Yeah.
Okay. It's just maybe one or two adjustment can work already.
Okay. I'll do a simple. Okay.
Okay, go all the way up.
Okay.
You see,
Okay.
Start.
Start.
one of eight on.
Okay.
Okay, go down.
Go down.
Low level on.
Switch.
Okay.
Press second.
Okay.
Okay. Okay.
Okay.
Okay.
Wait. So stop one A, one B on. So actually these two same, right? Actually no need this one.
Okay.
Okay, but never mind.
Hmm.
Then when high level on,
Whatever. Okay.
off the mixer. Slowly. Pump on, right? Now mixer is keep on running, right?
Yes.
Why?
Here we go.
Why keep on running?
Hmm.
Because of what? Any idea? If you see here,
Hmm.
after this, of course, this one on, right? So of course, it will cut off the mixer, correct?
Yes.
And when the mixer off, this memory off back.
Hmm.
So that's why repeat. Because of what? Because of this stop valve B. Correct?
Stop.
No, don't see here.
Hmm.
It's not that. Just see here. Why this one is continuously running? Any idea? Because of what?
All the symbol.
No. Because of this one, right? But I cannot see because of course we cannot see properly because very fast this memory. Okay, so I draw it here. You can have a better understanding. Okay. You see, you put the stop here. The M0.1, the mixer, right? Then mixer, timer, and 0.3, right? And you use here. How this one work? See, normally this is normally closed, this is normally closed, right?
Yes.
When high level on, you on the memory, correct? Correct? On top.
Which one?
On top the high level. When high level on, you on the memory, correct?
High level on stop up.
I mean on the memory, right?
Oh, on the memory.
On the memory, yeah?
Okay.
Okay. So, how it works? So when this one on this,
Okay.
so because this is normally closed already until here, right?
Yes.
So when this memory on
Mm.
the mixer, when the mixer on, timer, after the timer, this memory on here, correct? That's how it works, right?
Okay.
Then when this one on, what happened? Here we cut off.
Yes.
When this one cut off, what happened? Off this, off this. So here will off,
Yes.
this one will off, timer will reset. When timer reset, this one will off, correct?
Yes.
And this one off.
Okay.
So when this memory off already, here become normally closed back, correct? Then it will on the mixer. Okay? So now, why the mixer is on again? Because of what?
The memory.
This memory, right? Because this memory is still on, correct? This memory I get from where? From the high level.
High level.
So since the high level is always on, so it's triggered this memory to always on. I used this memory to on the mixer, so it is repeating.
But the memory tree cannot on. So that's how it.
No, it can on, but on immediately off.
Oh yeah, you have no current.
No, you know how it works? Because I'm writing slowly, yeah, that's why it's like here. So when after mixer, this one on, after 10 seconds, this one actually on, but visibly we cannot see. Okay? You see, after this memory on, when this one on, here cut off already.
Okay.
When this one cut off, this one of course this one will off this, off this, off this. So this memory off back.
Okay.
But this one happened in milliseconds. So that's why we cannot see this memory is on off. If no, how the timer can reset? But if the mixer is not turned off, how the timer can reset?
It means the memory tree have to change to memory open.
No.
Moving too fast.
No. The problem is this one.
Okay.
Continuously giving signal. You remember just now we do this. Just now when we do the testing, we learning the set reset everything, right? You remember? The switch on the motor, and I use the motor, timer and memory, right? So if I use this memory, it was repeating. Correct? Why the motor repeating? Because the switch is always on. So we change this into pulse, right? Same concept here. So your high level, because this one we cannot actually, this one also can use a pulse lah, but we see. So from where? From where I get?
From high level.
From the high level. So high level is continuously giving signal, so that the mixer cannot stop. But I can go and off the high level. But here I can off the line one.
You mean high level put the pause?
Yes, can put the pulse. High level want to put a pulse, or this memory want to make it into
But
pulse.
if they say high level put the pause, right, they mean that memory have to put the S.
Not necessary.
If let's say pulse, that means memory didn't activate the memory open.
Okay. If this one you put into past, I know what is question, right? That's enough. So this one also now what happened? It become so this one pulse, right?
Yeah.
So here also it become a pulse, right?
Okay.
Correct.
Yeah.
Here also pulse. So of course that the pulse cannot activate the mixer.
Yeah.
So that's it.
Oh.
And that's this way. Why? Because the stop you put in front.
Yes.
So you latch here lah. If the stop is here, then you latch normal lah.
Let's say I don't want to use pulse. I don't want to use
But you don't want to use pulse.
how to
Okay.
train.
Okay. You say okay, don't want to use pulse.
Yeah, I don't
Okay.
want to.
Now the idea is what? The timer is repeating. Why? Because the mixer is turn on and turn off. So I don't want this one to off. So what I do? When the timer on?
After mixer running.
No.
After the
When the high level on, of the VB
Yeah.
already done, on the mixer already done, you can use the high level to on the timer. Correct or not?
Okay.
So I use this memory here
Then memory will on the timer.
on the timer. Then so nobody going to off this. This one will off when the high level is off.
Yeah.
So this one will be continuously on.
Yeah.
So the moment this one on, mixer on ready. So at the same time timer run and this one will cut off.
Aside from beginning, I'm using the here memory.
You can use that also can, straight away the high level also can. Actually if you ask me, you don't need this. You know why? Yes. You will not need this one. Because you can put high level straight away here. You can put high level straight away here. Because you know why? Because it's the same thing. High level on, memory on.
Yes.
Unless you have some interlocks, then it's okay. No, just use the high level itself, it's already okay.
Configuration. This one.
Wait. No. Wait, slowly. Not that one. Not this one. Mixer here, right? This is what you need to change to the VB. This one is undo. You undo. You undo. This one need to change to the yes.
Distribution to the
Downward. Now mixer off, okay?
Off.
Why? You go up. Because you see, because this memory now is continuously on. Earlier I put mixer right, so you macam off on. Okay, now you off the now pumps on.
Yes.
Now you off the high level.
Okay.
Okay, what I do? Mixer on. You go up. Your valve be on bed ready. Can you see? Right.
Yes.
Why? Because you see, the moment you off the high level, right? this memory also off already, correct?
Yes.
So when this memory off, here just now it open, right? Now close back already.
Yes.
Okay, so when it's closed back, one be on, right? Because of what? Because of this memory. Okay, now you go up. You see why this memory is still on. This memory is still on because of the timer. Right?
Okay.
Because low level still on, right? So timer died. After the timer, this memory on, correct? And this memory is continuously giving the signal.
Yes.
So how to off this memory? If you want to off this memory, you need to off the timer. If you want to off the timer, the low level need to be off. Correct?
Yes.
But you cannot simply off because the level is not yet dropped, correct? Because the moment you off the high level, one be on battery. Top up. Correct?
Okay.
So now the question is, why I need this memory? What is the function of this memory? What this memory do? This memory do
So.
off the valve A and on the valve B, right?
Yes.
After that, I don't want that memory, correct?
So we'll give it a pause.
No need. I mean, you understand that or not? Okay, this one I need for off the valve A and on the valve B, correct?
Yes.
After that, I don't need to do, correct?
Mm.
So actually here you can put the interlock of valve A.
Interlock warfare.
Yes, you put normally open valve A, you put then you understand. You put and you test first. Put here valve A. Valve A. You delete valve A. Okay. You go down, go to your pump. I want to see your pump. Level, high level, on. How to off stop pump? You didn't off the pump, is it? You put normally close. I will tell you. You put this one beside here. Put normally close here.
This one change.
Normally close. Okay, the high level also normally close. You bring to here. Okay, you go up. Go up. Go up. Go up. Go up. Okay, save download. Okay, so you see, I put interlock here because you go on. We just see these two only. Okay, start. Okay, so when the valve A on, right? Okay, now low level on. So you see low level on, valve A on, timer run, right? After that, this one will cut off the valve A, right?
Yes.
When valve A off, you see here off already.
Okay.
So the timer already reset. So the stop, this memory is not always on.
Okay.
Earlier is always on. That's why the valve B repeats. Okay, now you on the high level. So finish. I cut off here. So now if I off the high level, I cannot on back the DB.
Okay. Off the high level.
Never. Go down first.
Okay.
Go down. Go down, mixer off already. Now the pump is on, right? Okay, go down. You see why I do like this? Because now both the switch is on. Correct? So you off high level. Okay, you off low level. Then only this memory off. Correct? Now you can use this. Put it here to off the pump. Okay, go up. Go up.
Switch off.
Okay, start memory. Okay, go down. Okay, go down. Set. Okay, go down. Go down. Okay, go up. Start. Okay. Low level. Go down. Okay. Or be on that. High level. So off, go down, up on, okay. High level off, low level off. Reset this, up, off, okay, go up. Okay, so off, nothing on back, right? Yeah, it's okay.
For the stop button is because it's normally open, so I
Set the off.
so I use for the set.
Oh, okay, okay, can also. Not the issue. You can direct put the stop here also can, or this way also can. Okay.
I do have a question.
Hmm. This is yours, is it? Which one is it? Okay.
One issue is like I want to interlock the high level and low level.
Hmm.
You see now we off, right?
Yeah.
We turn on the high level. Yes.
Suddenly off.
Yes. And I try to like interlock like mean before this LL activate. I mean if LL not activate, right, your HL cannot activate.
Hmm. So where is your HR?
Which line?
HR.
HL is over here.
This one, right?
I use pause.
Hmm. So
But
actually,
Mm-hmm.
you can use the valve key here because
This one.
no, this valve key.
Or
This
this
is
one.
off valve key.
Okay.
This valve key because no, go down, go down. I want to see these two lines.
Okay.
So if valve B you put here as interlongly open means if the valve B is on and high level on, then only it can on this memory.
Okay.
No need low level. Hmm. Valve B. For low level also same. Go up. For low level you already put the valve A.
Yeah, that means I need valve A on first.
Then
Okay,
only
now-
yes, the same concept for
Valve B here.
valve be on first, then the high level on, I on the memory.
Okay,
Because,
then
because this is the memory I used to cut off, right?
yeah.
Then it's okay.
Okay.
Just one question.
Hmm.
The tech table now is like before tech table.
Hmm.
How can I put it like all the inputs on one
Yeah,
tech
can.
table or outputs on
You add new tag table here. Okay, you rename this.
this one
Yeah. So what do you want to do?
inputs.
Okay, put inputs. Okay, then you create another one for outputs, is it?
Yes. So this one, this is the original one, the default one.
Okay, you can name it output.
Output.
Then the memory, where you want to put? Want to create another one for memory? Okay, no problem.
How do I?
Yeah. Okay, now we go to show all tag. The tag table here, you change. You click here, change to inputs. Okay, so just drag like an Excel sheet. No, here. Yes. How many? 4, right? Okay, enough. Override that, yes. Then the Q all is output, is okay. It's okay, output. And start with the memory. Here. Yeah.
Yes, yeah.
Change the memory. Change the tag table to memory. Okay, right. Yes. Okay. Now you open one by one, you can see all. Okay. You click here, outputs. Double. The output, inputs, memory. Got it?
I saw on
Your project,
yes.
yes.
Some programs, and I was wondering how they came up with this.
Yes. Because when you do projects, right? When you do big projects, of course, you put like this. Even some I also do projects. I will put input. Maybe I put input output. If not more I/O, I just put input output in one. This one. Then all the memories, others in another one. So easy for me to trace, do programming. Because when you do programming or so many this one, sometimes you also fed up, confused. Like which one I
Itemize all the folder everything.
all okay. Bawa apa? Just want to check. Yes.
Still remember yesterday we did the learn regarding the IP address, right? At which area already I can't remember.
Okay, right click. Open network. Go all the way down.
Now,
Change adapter option.
oh, so
Yes. Ethernet. Properties.
okay.
TCP/IP4.
TCPIP.
The last number. Oh, TCP/IP4.
This one?
Yes.
Oh, okay. Property.
Property.
Oh, okay.
So what do you do? You can try lah. Try.
Okay.
Take a picture.
Easy.
Yeah.
But no, sometimes you confuse so you way to find it.
Yes, yes. You can take picture of. Actually, where's my book? The manual. Inside the manual also.
Oh,
By the time
yeah.
I take picture, want to write, you can type. Moses, how was the hotel? Okay?
It's good that it's just nearby, so
Yeah.
it's easy. So I was with there was a project when I was still working with BAT, and there was a software, a PLC programmer. So we did the upgrade in the factory. So I was looking at how he established connections between PLC. He used common prompt and then he ping.
Okay.
Yes.
Okay, that is command prompt ping is to check my laptop and the device is connected or not. So your laptop IP address and the device IP address, the first three number must be same. What's that? Ping means it's just to check the cable is okay or not. That's all. That one you can do for any device. Not only PLC, HMI, even some house device that is using Ethernet, you can do that thing.
there is no module, configuration of the module, like starting address and end address, is it the same as S7-300 and 1500?
Same.
Same. So you will click on the input card,
Yes.
and then you go to properties.
Then you can change.
Starting and end address.
Yes.
Just the same.
finish.
Okay, thank you so much. So, let's say we without connect, we can use the force level to force it. Let's say we without connect the PLC, using the force level, you know.
Yes, can.
Yeah.
Use the simulation.
Okay.
Something like PLC people you want to that they call you to write the sequence of the program. Is it like this? No.
Something like this one.
Or any specified like
No, like this. There's many ways. One like this. Oh, okay. Sometimes I have example. I have one example. Like this also. So they say what? Okay, you press that, initialize system parameter. Input. The solar is available, yes, okay. If no, you go to battery. This one they have one system, what for the what? The power system. So they use solar, battery, hydrogen to the house. So it will check lah. If the solar is there, okay, use the solar. If solar is not there, the hydrogen or the battery. Because after this I go to UTM.
You can.
Last week and this week also some every day after training go there. Do some project. I think there's a project so there's a problem with the project. That's why they want to increase the that's why I asked him for the what heating and they have a big box, this the box. The heater is this small only.
big heater.
Big chamber, the heater is this small only. So cannot touch the whole chamber.
Yeah.
So need to use a coil.
Oh.
That's why looking for
Coil.
Heating coil lah, heating coil.
You can use carbon one.
Yeah.
Because you know, using heating coil, how about temperature, how many degree?
65 only.
Uh,
But they use a small heater, this big only. This one can produce up to 100, but the radius of the temperature is this here only. The temperature can go up to here only. The chamber is this big. This is the width and this is the length. The height is 2 meters. So they only use 2, so not enough. So need to use some coil with the exhaust fan or fan underneath, so it's constantly flow. So I can use a PID to on off the heater. So first I on, so it can go up to maybe 60 degree plus. Then after that I maybe pulse on off. So I can maintain the temperature.
plus minus
Yeah.
plus. Okay, thank you.
Okay,
See you tomorrow.
see you tomorrow. Bye.
Anything just update me lah bro. Anything just update me